think the one or the other is still coming in. For those who are here, thanks for waiting. Thanks for bearing with us for the last session. We still have like 3 very interesting talks for today, and then I think after that we all go into the deserved networking session outside. So for now, I would like to invite Erik Hokanson on stage, please, from AE7. He's one of the design directors, and he will get us through a journey of facade designing from an architectural point of view. Enjoy.
Great,
Thanks,
thank you
Erik.
very much. So the presentation is loaded. There we go. So thank you very much for being here today. Just first and foremost, AE7. We are an international design firm, architecture, engineering, full scope of services. We also get into financial feasibility, master planning, market analysis. We have 15 offices worldwide, and we're headquartered here in Dubai. About 570 employees now. A lot of our work that we're probably most well known for in Dubai would be master planning work that we start kind of at the very conceptual visioning stage, and we take that through design and into construction. So the projects that you might be aware of would be District 1 as part of Mohammed bin Rashid Al Maktoum City. Phase 3 as part of that, that's touching the Crystal Lagoon, Dubai Water Canal, and some of the other projects that I'll touch on. This is just kind of like a quick look at some of the projects that we've been involved with in Dubai and elsewhere. So the title of the conference is Facade Finesse, Design, Articulation, and Performance of Icons. So really what I'm going to touch on, they're more or less case studies. We'll talk a little bit about the architecture itself, and then I'll try to walk through the different systems that we looked at. Of course, we're designers, architects, and engineers, and we bring in specialists to work with us on facades. So the likes of Colte, Mindhart, also Eckersley Callahan, when we're fortunate, as well, that work with us on some of the projects. So 5 Lux Tower in JBR, Sensoria Tower, which is under construction. 5 Lux is just finished. We have a net zero energy tower that we designed that we'll showcase for you. And also the new exciting design for Burj Azizi on Sheikh Zayed Road. It was the former Entisar Tower with Meydan, and now Azizi has taken that project over about 2 years back, and we're designing a very exciting project for Mr. Azizi. So first and foremost, we'll touch on 5 Lux. 5 Lux originally started with us back in probably 2011. It was a Meydan project, and it was called Meydan Beach Hotel. We presented this project to Sheikh Mohammed Al Maktoum. We got approval for the project, and we moved forward. It was a hotel project at that time. And a few years later, after we'd nearly completed the design and started construction of the tower, 5 Holding purchased the project, purchased the site, purchased the rights to the project, and from that point forward, we designed it as a 5 hotel. And the exciting thing about that, or the interesting thing about that, is it converted from just being a hotel to being, as part of his business plan, Mr. Kabir, was to do a hotel and also branded apartments as part of the offer. So, whoops, so let's see. So the bottom part of the site here, the podium, if you will, basically is the hotel, and the tower here, obviously, becomes branded apartments. And in the 5 setup, the way it kind of works, and this is in our initial concept, we were looking at projects like the Delano in Miami, things of this nature, which have kind of a podium that surrounds a beautiful infinity pool. This, of course, the scale is a little bit different. But in 5 itself, similar to the 5 that you see in on the Palm, they create an amphitheater. So it's the show. And if you've been at 5, you know what I'm talking about. So this is the render image. One of the important things for us as we started the design was creating a window. So from the drop-off on the JBR side, when you arrive at the hotel, you see straight through the lobby, the grand lobby experience, all the way across the Infinity Edge pool and into the sea. So it's a pretty exciting experience, and we'll talk a little bit about the curtain wall that was designed for that. This is the top-down plan. The other interesting thing that we got approval for on the sign-off sheet was building in the water, which was not happening at JBR at the time. And the initial design, we actually had some luxury villas and we had kind of a spa. But when 5 took over, that turned into a club. And we originally had a club called the Rig. And now that's transformed into, if you're familiar with Leo, which is a brand out of the UK. So this is the view of kind of the amphitheater, if you will. You have the different levels of experience from the pool, the day beds, the cabanas, and into the feature suites that happen on the project. This is an actual built construction photo of the pool from the beach side, and some of the different facade components that I'll get into in just a minute, and then from afar. It's actually the tallest structure in JBR itself. It's 55 stories, 230 meters tall. There's an amazing penthouse at the top that has a beautiful outdoor pool. So we'll get a little bit into the facade types. We have unitized stick and curtain wall. I should say that Colte was our facade consultant that worked with us on this project. Glazed louvers for the mechanical areas gives us a really beautiful seamless facade. We have aluminum sunscreens and trellis elements that occur at various points in the project. For the window area in the lobby, we used a cable net system. Whoops, back one. And we used patch-fitted facade for the panoramic elevators. All the units in the project face the sea. That's really the view. The view's not back towards JBR. But if you're riding in the elevator, you get a view back towards JBR, which is quite nice. And then we have a metal-clad facade that has a dynamic lighting system. So first, the curtain wall areas, what you would expect, floor-to-ceiling glass for the units, typical storefront type of a detail with a aluminum clad system around that, and also stick systems. The MEP floors you see on the top, where we have the staggered glass facade. Those units we're using on various projects. It gives a very seamless glass facade. It's quite nice, actually. And then trellis elements that you see on the feature suite units that act as sunscreens and provide shading. This is the cable net system. It's actually about 19 meters across and I think 16.8 meters high. The typical glazed units are 1.2 by I think 2.6 wide. It's quite nice. This is these are the details, the zoomed in details. It gives a very seamless, mullion-less feel. And this is a quick amateur video kind of walking into the lobby if you haven't seen. We were fortunate this day, there was actually a boat in the distance. So you can see straight through. And what you see in the distance on the right is a really, really cool 3D screen that's been put on the Sensoria Tower, which is the next project I'll talk about. So you get a real sense of the clear view of that. These are the panoramic elevators that go all the way to the top of the building. And the patch-fitted facade. We're really trying these days to stay away from puncturing glass. We're trying to make sure, and we've been doing this for a while, but we're trying to use patch fittings where we don't put holes in glass because it puts undue stress on the glass, and we can do a lot more things and get better sizes and less breakage if we don't do that. This is the metal facade with the dynamic lighting. And this study we actually did both for this project and the next project I'll show you, where we looked at various glass options. Really, option 1 and option 2 were what we focused on. We looked at a sage glass option, which is option 3. Sage glass, if you're not familiar, is kind of a user-controlled system where you can actually kind of direct the facade itself and allow how much shading you want to have in the facade, but it's very expensive. It works very well. I was actually in a hotel in the US about 2 years back, and I had an iPad, and I was able to control I was in a penthouse, and it had a slope glass. I was able to control that in an amazing way, but it's extremely expensive, and of course, if you're a developer doing a project, you're probably not going to look at that when you're only seeing about a percentage or a percentage and a half of performance increase over the life of the project, and it's a 10-year payback. So we looked at the low E. I should also mention this project, and you have to commend 5 for this. All of their projects are LEED Platinum. So we're LEED Platinum certified on Lux, and the Sensoria will be LEED Platinum. Their current hotel, 5 Palm and also JVC, are all LEED Platinum. They actually have nearly as many LEED Platinum rooms as the entire United States. I know this because I did a talk in New York recently with Kabir on the Net Zero project. This is just touching quickly on high-performance glass benefits and versus the smart glass systems. And really, the main difference is kind of the uniqueness and full automation. It's really user control. And you can see, obviously, the mechanical and ELV play a huge part in design. This is really a chart about hotels, but most projects. So anything you can do on the facade to increase and have better performance is going to help that top end. The next project I'll touch on is Sensoria Tower. As we were far into 5 Lux, we noticed on the affection plan, actually, that we had about another 20,000 square meters of developable area. So there was the intention to put a new tower. So where do you put a new tower? We had to look at access and everything else. And we decided to put a tower kind of on the front right. And the tower is a residential tower. There's 53 units. I believe it's 39 stories, 194 meters tall. The first 11 floors of the building are automated parking. And we shielded that automated parking with the largest 3D screen in the world. So it's on the face that you see here. It's at the very bottom. This here. It's actually 40 meters across, and it's 20 meters across the other way. So these are the screens that you've seen, I'm sure you've seen on YouTube, where things project. They almost look like they're coming out of the screen. So it's going to be a really dynamic experience as part of the atmosphere of 5. And then the bridge extending out is taking you to Leo, which is the club that will be constructed in a few years. This will be built in Europe somewhere, and they'll ship it here, and then it will land on the foundations of the project. This is another view you see here. So one of the kind of iconic moves for 5, they kind of started this, was having plunge pools for each unit. So what we started to look at, the early concept was, how can we fold the floor plane to accommodate the plunge pool and design the acrylic edge into the handrail system. Here's a view from the water and kind of a detail view. The views of the tower all look towards the wheel, all towards the island. And then just touch on the facade systems here. We have, of course, unitized stick curtain wall. We have the glazed louvers again. CFRC cladding, which is covering all the edges around the project because we have that curved edge. Acrylic pools. We have the LED screen. And the other thing that we're building, it's the first of its kind on a tower, is the Onyx solar panels that will happen on the back side of the tower, actually the south side of the tower. They'll provide about 40 kV worth of power. So this all goes into the LEED Platinum system we're looking at. So the stick systems you see, floor-to-ceiling glass. We work closely with Colte on this one. We did a better job than we did on Lux. We got nice thin mullions that we were pushing for. These are the mechanical floors with the mechanical louver systems. The acrylic pools that were designed into the project. These are part of the experience of 5, so you have that as part of your unit itself, as your branded villa with a view. And then this is the screen system, the LED screen system that goes around the automated car park. So we didn't have room in the basement for parking, and we didn't really have room for a parking garage, for a podium, so we had to use automated parking. And it's a pretty slick system, actually. This is a small video, I think, of the screen. So this is the digital screen. This is that amphitheaters you see, and then the 5 Lux Tower. And these are the details. This is actually shown in the middle as the mock-up panel. We have to mock this up because they haven't done it before at this height. So they've done it, I believe, the maximum height they've done is like 12 stories. And we're pushing 40 stories here. So this is the design of the facade panel itself and how it works. So another interesting endeavor that we embarked on was the idea of a net zero tower. And this project originated in Albarari, a community kind of out off of 311 near Global Village. It's a very nice upscale community. And they have a new master plan, and there was a site available. So we looked at a site there for a net zero energy tower. And this was 230 meters tall, 31 stories of residential. This is the top view. We worked, on this project, we worked with a consultant called Atelier 10, and they were our sustainability consultant, and we pushed real hard, of course, on how could we achieve net zero. And one of the challenges that any of you will face if you try to do this in Dubai is DEWA has a limitation on how much solar energy you can produce on site by yourself, because they've created a wonderful solar farm out in the desert, and they want you to buy that solar power. So we ran into problems at some point with DEWA that this project was not feasible in Dubai at this time. Maybe it will be in the future. But we're looking at doing this project in other locations around the world. Miami, potentially Vegas, Australia, and some other locations as Five expands their product line. So this project is modeled very closely after their design in JVC, which is a corkscrew design. It's very interesting, which allows for kind of landscaped units off of, or landscape areas and terrace areas and pools off of the residential units. And it also allows for a certain amount of air to circulate up and within the building. And you can see the elements that come off the side of the floor levels, those are actually sunscreens that are solar panels, and we've designed those very specifically. There's the podium level and amenities for the residences, kind of a view of the pool and the city beyond. Entrance. So these were some of the key sustainability features that we looked at. Of course, solar panels were the bulk of the power that we're able to harness. We looked at BIPV balustrades. We looked at solar tiles, shading elements, all kinds of things. Wherever we could bring things in. Also green walls to help clean the air and offer respite for residences. This is a general sense of the plan. So as it steps around, you can kind of see. And we had 2, 3, and 4 bedroom units. So the terraced areas, we figured out, we calculated all the terrace areas we had. We had the equivalent in this tower of 4.5 football fields. And the solar panels, there's 12,700 plus solar panels. And these cover 5 football fields if you add all of those units up. And then these are some of the studies that Atelier 10 did with us to actually measure and study the solar power. So we looked at a sun dome, we looked at the orientation. Being a curved building was quite interesting because we were able to really focus on certain areas. And we could focus how deep the panels wanted to be and actually at what angle the solar panels wanted to be to achieve the highest value of solar gain. And then basically what they do is quite clever, is they have a model that they run where they can optimize and look at the complete optimization of all kind of systems that we were looking at and figure out which ones are best for cooling, energy savings, et cetera, et cetera. So these were the balustrades, and then these were the solar panels, which also acted as sunscreens on the south facade in the heat of the summer. So they would block the sun to those outer units where we had clear glass, and they would also harness power from the sun. And the top of the tower actually is where we got the most benefit, of course, the top where we were able to angle the top of the tower to really do a great job of that. So we're able to achieve 103.1% of the power requirement for the building, and we're creating 5.71 megawatt hours of power for the project. So last project I want to touch on real quickly, very exciting that we're doing for Azizi. This is on Sheikh Zayed Road. This is being designed as the second tallest, or the tallest, sorry, residential tower in the world. It'll be the second tallest tower in the world at 725 meters. The site originally, as I said before, was a site that Meydan had owned, and we had looked at a tower there before around 500 meters, but with Azizi we're pushing even taller. We're going for a very vertical expression to this project. This project has on the ground level, ground plus 8 is a vertical retail mall. We have branded apartments. We have residential units totaling 1,000 total. We have a hotel with the lobby at floor 111 and 270 key hotel. We have an adrenaline zone at the top. And at the very top of that tube that you see, that's 647 meters, we actually have an observation level. So we have a lot of really exciting things going on in this project. What you see kind of towards the back end, this is typical for a lot of buildings along Sheikh Zayed Road, is the parking, which also in that structure we house, we have the basically a space for weddings, and on top we have a club element that's a beach club and whatnot. The tower itself also has 8 restaurants and a nightclub at the very top. So this is the ground floor. You can see how tight this is. It's a logistical nightmare, to say the least. We have over 47 elevators in the building. We have to look at all the drop-off conditions, loading conditions, et cetera, as well as all the different facade elements in the project. This is the general stacking that I just talked through of the project and the different floor plan configurations. The ground level, the first 8 floors, as I said before, are retail and also entrance. And then some of the lighting schemes that we're looking at. This is the garage, and I'm going to talk specifically about the garage because that is under construction right now. The foundations for the tower are in. They're actually Brett foundations. The garage itself is under construction. We've been looking at the facade. We're working with Sedek on this with bent glass panels to help us with some of the ventilation requirements of the garage. So, of course, we have unitized curtain wall systems. We have, again, the metal slot balconies for the MEP, a double facade for the ground level. Eckersley O'Callaghan is helping us with that. I believe James is speaking tomorrow. We have a glass cube for the hotel lobby that also James is working on. Eckersley O'Callaghan is D. Adrenaline zone at the very top. At the very top, again, F, we have the spire element, which are steel elements that extend in the sky. Those will have some type of a screen element we're still working on. We have a glass box on the podium that looks into the multi-purpose space. It's a really interesting design. We have the curved glass blades that I spoke to, and then we have also vertical metal blades to accentuate the verticality of the tower. So this is the garage structure. We've designed almost like a unitized system for the garage and the curved glass panels. So we have basically steel frames that attach to the concrete structure and then the glass panels attached to that. And these were the stress tests that were done on the curved glass panels. They look like this. The other interesting thing, again, we're not puncturing holes in those panels. They were creating too much stress, and we're gonna have to add additional members. So we're actually using an adhesive, which allows for some movement, and it hangs off of a really quite small bent steel plate. And then the other element that we have that's quite unique is this glass box, which has very minimal mullions. So basically, we're looking at a frosted glass element, and we have a built-up glass member with virtually no mullions vertically, just a very small silicone joint, and then horizontally we have a very small band, and that's all kind of hung off of this steel pipe and a cable system. So this is the look of the tower from basically the Al Ain Road. You can see kind of the skyline of Dubai. This is one of the best views of Dubai if you haven't seen it. And that's what I have for you today. So thank you so much.
Thank you so much, Erik. I have a question from the audience for you.
Sure.
How sustainable is sustainable if you have pools on every deck in your building?
Well, I mean, look, you have to give and take. How sustainable is it to build anything in Dubai? I would ask the question, if you want to go that deep. The reality is that, yes, you're going to have some evaporation, this type of thing, but the buildings as a whole are LEED Platinum. So we're doing other things with water, we're doing other things with solar power, et cetera, to offset that type of a thing. But yes, I mean, putting a swimming pool, any kind of water that you have sitting outside is going to evaporate. So that's not probably the most sustainable thing, but in general, I would say buildings that are achieving a LEED Platinum certification, kudos to that developer.
So it's a balance, yeah?
It's a balance, right? Like with everything else.
All right, thank you very much
for
this
so much.
Great presentation. And last but not least, I think we have 2 more speakers. Davide Davide von Florim. We practice how I say his name so it doesn't sound French. David, please, the stage is yours. And he's going to speak about ceramics.
Panels, correct.
Ceramic panels.
Yes.
Okay.
So, hi everyone, nice to meet you. I'm David. I'm from Italy. I represent here Florim. Florim is an Italian company based in the north of Italy, close to Ferrari. I'm sure that most of you knows about Ferrari factory. We are just next to them. Let me spend only a few words about Florim. We have basically 2 production plants in Italy, in north of Italy, and 1 production plant in the United States, only for the local market, in the one in the United States. As you can see on the top of the slide, we have flagship stores all over the world, from Italy, Moscow, Singapore, where I'm actually based, Frankfurt, London, Abu Dhabi, Paris, Rome, Los Angeles, and we're going to add another 2, 1 in Korea and 1 in Dubai soon. One of the main characteristics of the company is the big attention to the environment and to the sustainability. That's why in the 2020 we became a benefit corporation. This one was the first step in order to achieve the big corporation. We are one of the few companies in the world ceramic companies, having this certification. And this certification is not only a certification about the product, but it's a certification about the company itself. So basically, they test what you take from the environment and what you give back to the environment. So based on this score, the minimum point that you can achieve is 80, and as consolidate score between the Italian factory and the United States factory, we got 90.9. And then a good thing of this certification is that you need to improve yourself daily, and so every year you need to improve this score. If you don't do that, you will lose it. Big sustainability, a big attention to the environment, as I was mentioning, 100% water recycle. We are able to produce the whole energy for the factory by ourselves. And from last year, we also produce carbon zero products. More than 90% on natural material, 24% is the average of recycled material inside our product, and more than 20 tons is the certification that we have. How you can see, we have all this worldwide certification in terms of sustainability, in terms of green product, as Bureau Veritas, LEED, Green Guard, and so on. And of course, we have also the local certification, and so we can supply locally and all in UAE. But let me show you how we produce our material. Everything starts from raw material, natural product.
Everything starts with the soil, with the pursuit and selection of the finest raw materials nature has to offer. Precious ingredients are carefully mixed, ground, and dried. A conveyor belt leads them towards the rollers, where they are carefully pressed. They thus become an uninterrupted, soft carpet, which continues on its way to becoming Florim magnum oversize in its immense proportions, reaching a size of 320 by 160 centimeters. The cut slab is ready to be dried again and embellished with digital graphics. At this stage, it enters one of the many kilns that fires it at more than 1,200 degrees. This process makes it solid and hard-wearing. Flooring. Design is our passion.
Okay, how you can see with this new evolution of the porcelain of the ceramic panels, so we are able to achieve huge slabs. The biggest one is 1.6 by 3.2 meter, and these products are, of course, suitable for indoor application as well as for outdoor application. That's why we propose also for facade application. Why? You cut a lot of the number of joints. You put on the facade a product that basically is maintenance-free. Later you will see the technical specs. It's light. We can install on the facade 6mm panels, so we reduce a lot the weight on the facade, especially for seismic load. And it is resistant, of course, to the UV, to the high concentration of acid, to the weather condition. It's scratch resistant. It's completely waterproof. You will see the water absorption is 0.08%, so basically zero. And the range is so wide that you can have all the look they are looking for, from concrete look to marble look to stone look, and so on. Well, let's go in details. Of course, these systems are also called double skin or ventilate facade. And of course, they have all these advantages. In terms of aesthetic, you can achieve all the aesthetic that you're looking for. The water will never touch the actual wall. That's why also they are called double skin. And in terms of energy and healthier environment, the cavity helps you to dissipate the sound waves as well as having a natural insulation of the building. Some example of a static point of view, you can custom made that we can water jet the panel, we can achieve all the size that you're looking for. So not only the graphics, but also the size of the panel. The color won't change, so it's stable. Also, like for very high temperature and very low temperature as well. It's possible to replace the single panels in case it's needed. So we are able to match the same exactly tonality. That is a limit that, for example, you cannot do with the stone or with other materials as well. And they are resistant to the atmospheric agent. It is also possible, of course, to wash the facades as you wash the curtain wall, basically. Technical specs, as you can see, the water absorption, the most important value, is 0.08, scratch resistant, resistant to the staining. So whatever is dirty rain, whatever is like the components inside the rain, they won't affect the panel. It's frost resistant for very cold country. You will see some referencing from Canada or Quebec, where they can also achieve -30. And it's also resistant to high concentration of acid. So when we have like the acid rain, these won't affect the panel look. As you can see, also another really important fact is that the coefficient of dilatation is very, very little. If you consider the big panels, 3.2 meter, having a different temperature of 50 degrees, you have only dilatation of 1.2 millimeters. So that means basically that you cut the dimension of the joint. So you can reduce the joint to 5 millimeters. Of course, so we don't offer only the panels, but we also offer a solution. Let me go straight away to the video where we introduce. Sorry. No. Okay. So of course, it's a dry installation. So behind the slabs, there is a mechanical system. So everything starts from the very structure of the building. We install our brackets and the profile. Okay, this process has been done on site, but exactly the same process can be done also in the factory. So we can precast the panels and just ship to site when they install it. In this specific moment, they are applying the primer, because in the middle of the profile, of course, you cannot screw anything, and so you need to have a structural silicone able to absorb the vibration, basically, to dissipate the vibration of the panel due to the wind. Okay, in the back, you can see there is basically a miling, and we inserted this hook. It's a stainless steel hook, so it's flexible, but at the same time, very, very resistant. And you can see the darker part of the slab in the back is the fiberglass mesh. This is an additional safety element that we apply to the panels. So in case of breakages of the panels, no one piece will fall down. It's basically as laminate glass. And then all around, we screw the hook on the profile, basically. This panel is only 6 millimeter. So this one is one of the few systems in the market with all the worldwide certification able to be suitable for this thickness. Then you will see there are also supporting plates also during the installation, so it's like quite smooth the installation for the installer, since they can drop the dead load of the panels on those plates while they have free hands basically to screw the hook on the profile. You can actually custom-made the facade, so we can actually achieve the look of the specific graphic that you're looking for. In this case, we custom-made it with the mountain lake that we have in Italy. And this is the final result. Okay, of course we test the system with worldwide certification, and in terms of wind load, we achieved 4.5 kPa in negative pressure, but this was the maximum load achievable by the machine. We never tested with higher value because usually this product, I mean the building that we supply for, usually they are fine with this kind of negative pressure. ATA certification, European Technical Assessment, where of course they test in terms of wind load, fire resistance, impact resistance, and so on. Fire resistant, okay, the panel itself is not combustible, so it's class A, okay? The system itself, since there is of course the silicone, it can still like generate a bit of smoke, and so the full package is classified as limited combustible, so class A2. Now we are in the process of developing a system which is in class A, so completely not combustible. Seismic test done, we achieved 2.5 G, which is the gravity acceleration, because of course from some countries, Japan or New Zealand, when we supply our system and products to, this is needed. And this is like a homemade video, I would say, but it's quite nice to see the resistance, because sometimes the question is 6 millimeters strong enough? So this is 50 kg soft body in the middle of the panel where there is no metal frame. Of course, we have also the official testing, but this is just to show you as like this video, it can give you an idea, like a direct idea that the panel is strong, even if only 6 millimeters. How we assist the consultant or the architect and so on? Basically, we can suggest you all the layout in terms of optimization. So we have also a technical department in charge of this study. And of course, also the frame with all the details, calculation report, and so on. So it's an additional service that Florim gives to all the consultant and architects. So it's not just a supplier of porcelain product or slabs, but it's something more. And this, during the installation, this specific building is in Bangkok, just to give you an idea. And they install the wall panels with the details of the corner and so on, and this is the final result. The brackets that you saw before basically are the brackets of the signage, and of course we need to fix it on the main structure of the building, so we had to basically generate the hole on the panels, and through the hole we install the brackets. Some references worldwide: Torre Milano, one of the tallest buildings in Italy. Riva, this to show you that this material has been installed directly on the sea, because you see this is the sea and has no issue in terms of resistance, in terms of performance. Very cold country. This is in the United States with the, the snow, -50, -20, no issue. As well as very hot country. This is, for example, Korea, South Korea. this a small project just to show you that the application and the usage, of course, of this material is very wide. So you can go from residential to office to commercial building, as well as, of course, low-rise building. Thanks so much for your attention. We have, of course, our small booth outside, so please feel free to come and say hello. We will be more than happy to welcome you. Thanks so much.
Thank you so much, David.
Thank you.
David. Last one for today, Frank from Axalta, talking about powder coatings. Is it powder coatings? Talking about powder coatings. I hope you all have had the chance to take some pictures in front of the wings. If you don't want to stand in line for the Dubai wings in downtown, now you have the chance to do it with the Axalta wings. Frank, I would leave it to you.
Yes. Thank you very much. So I'm the last one. Thanks for staying. You must be a bit tired. Yes, so my name is Franck Derouen. I'm from Axalta Coating Systems. I'm the business director for Middle East and Africa. Before this assignment, I was the global architectural segment director for Axalta. So if you cut my head, maybe you will see powder-coated aluminum coming out. I'm really an architectural guy. First of all, Axalta is an name. It's a coating system. We manufacture coatings, and more precisely, we manufacture powder coatings. And we are established in the Middle East since 2019, and we manufacture. We have a factory in Ras Al Khaimah. Okay, I'm going to drive you through what we call a project journey with Axalta. And this project actually has 4 stages. What we call project excellence. See how we learn how we support you in all the coating aspects of your project. Continued education, because we believe that education is key if we want to ensure long-term quality. Defining quality is how we support you in your specification. How we make sure that the products we will supply to you will meet the expected requirements, especially in terms of performance. And color and finish, which is at the end of the day what people see when they see powder coating. It's a critical aspect of our business, and of course we have a lot of tools and services for specifiers. Project excellence. So that's the first stage. It is, I mean, we have a team of specification specialists or specification leaders, and they are very experienced, and obviously they are here to be your trusted advisors when it comes to coatings. So we have, I mean, they all have a very deep technical knowledge, whether it's about the coating, of course, but also about the substrate and about the surface preparation. We also have kits for problem solving. Sometimes problems can occur, I mean, during application, during even constructions, during the transportation of the coated element to the sites. So we are here to help and to find solutions. Axalta Coating System is not only a powder coating manufacturer, but also a liquid coating manufacturer. So we have a lot of solutions, for example, for repair in case of damage. So we believe that we have to be very close to all the stakeholders of the specification chain, and we are not only close to our customers, the applicators, but we are close to developers, we are close to specifiers, we are close to consultants, facade consultants, and fabricators. Continued educations. It's an area we have been focusing on the last years. We are design a set of workshops, training workshops, when we can, on demand, come to your place and talk about topics, different topics. For example, sustainability. So it's a big topic nowadays. We can talk about sustainability. We can talk precisely about LEED. We have made a lot of research on LEED. We can talk about anti-corrosions, for example, which is also a critical point, and any type of technical topics. We are a partner really in continued education. I mean, education is part of the specifier career. I mean, they have to be continuously educated, especially in the worlds of the RIBA or AMA, and we have modules for I mean, that fit into the framework on these continued education systems. Quality and performance, very, very important. That's a critical point. We are here to serve you and to really offer personalized service and guidance that the coating we will offer you will match the expected performance. Okay, we are not building a tower for a couple of years. We are building towers for generations, for decades. So it's very important to make sure that our product we supply will match your specifications. And we are committed also to quality and performance, as we have also warranties. I mean, we give warranties on our products through our network of approved applicators. I mean, we always talk about aluminium, but we also have, and this is something that is quite unique within Axalta, we have solutions for steel. Although steel is not widely used in facade, it's still compared to aluminium, but it's still a topic, a big topic when it comes to anti-corrosion, and we are able to offer anti-corrosion for steel. Sustainability. It's also, I mean, something very important. Everybody talks about sustainability. Axalta has very high ambition in terms of sustainability, and we are already working on the future of the powder coatings. Especially, we are working on bio-coats, so bio-based powders that will use bio-based raw materials in the coating in order to reduce the carbon footprint and in order to protect the environment. And I would like to say that we are already awarded for our approach. I mean, although our product is still not on the marketplace, I mean, we have been, I would say, internationally awarded for the approach we are having on bio-coat or bio-based solutions. When it comes to construction, LEED is a benchmark, and we have carried out a lot of technical survey with external consultants, and we highlighted the fact that using Alesta SD or super durable, consultants can get up to 8 points for LEEDs, 8 LEED points. So that's also something that we can offer to the market. Color, finish, and effect, very important. Clearly, architecture has a design dimension where finishing is critical for ensuring the highest value of a building. Actually, at the end of the day, a lot of people in real estate call a building an asset. So the finishing is critical, and especially the durability is critical if we want to preserve the value of a building. So we have, I mean, our team are expert in colors. They are trained in colors, and they are going to meet with architects and designers in order to offer the best finish. Okay, not only the color but also the texture. For example, just here in the UAE we have more than 400 colors, but we can also I would say, design custom shades, as we have local R&D facility. It's a good case story here. That will summarize this journey. It's on the picture you can see a building. It's a historical building in Rome, okay, Via Veneto 89, which was built in 1929, and this building was recently renovated by an architect named Scandura Studio, and the challenge was to use powder-coated aluminium on a historical building. So we have been working from A to Z with this architect. So they came to our color experience room in Milan. So we have rooms with all the colors available. And they came and they select colors. And we made sure that the products that selected was matching their specification. And at the end of the day, the result is superb, because this powder-coated aluminium is perfectly matching the style of the building. And on top of that, the building was awarded gold according to LEED. Color in real life. So that's also an important topic. We have digitalized all our colors, and they are available as a BIM object. So architects can download the colors, okay, digitalize, and include them into their design scheme, so they can have an excellent and accurate view on what it is going to be looking in real. So this BIM object is already obviously available, because in many countries BIM is a must. So we are also bringing BIM, this option here in the Middle East. Oops, sorry. Inspiration for future projects. We also have tools that talk about colors. A lot of tools. It is called the Color Design Toolbox. So we call it the one-stop destination for all Axalta's innovative color tools and resources. So it's about color cards, but it's not only about color cards. We can design color cards for our customers. We can design color cards for OEMs. We can design color cards for system houses. Okay. We are also asked sometimes by designers or architects to install what we call color walls. So color walls it's a wall full of colors, color samples. So in those usually large architect office, they have a dedicated room, and architects when they work on a project, they can go and select colors and play with the samples under lights, different lights, and see and make their own choice. This is named the color wall concept. Of course, architectural is mainly about track record. First of all, I mean, we have to make sure that our products will last in the time. And we have, I mean, a lot of track records, global track records. It was difficult to make a choice, obviously, but just in some, let's say, bullet points. So Axalta started to manufacturing powder coatings in the late 50s. So we have basically 65 years of experience in the powder coating industry. We have 40 years experience in architectural powder coatings. And we have 22 years of experience in super durable. Our first building coated with super durable were finished in 1992 in Indonesia. Last tool I would like to share with you is what we call the Vibes trend tool. every year, we work with trend consultants that travel around the world and analyze the trends in terms of colors. And every year we gather with them, and we issue a magazine named Vibes that we widely send to consultants and designers. And this trend journal not only talk about colors, but talk about I mean, social effects, social trends, and link the social trends with the color trends. And we let the designers talking about colors and how they perceive and how they use colors in their day-to-day life. So this is what we call the Vibes Trend Magazine. Another color tool. Thank you very much. It's been a pleasure talking to you. Thank you for staying so late. And yeah, I'm very impressed that I have been on stage at the Coca-Cola Arena, like Elisa next week, and soon James Blunt. Thank you very much. And see you later. We have a stand. You can come. You are most welcome if you want to meet us. Thank you very much.
Sorry. Thank you so much, Frank. We think I have David, who would want to show us additional information about Florim. So with today, I think we are more or less like wrapped up. So we're just waiting for David to come back and give us some of his slides he missed apparently. But nevertheless, I hope you enjoyed it today. I hope you took away a lot of new inspirations and knowledge in our industry. We will continue tomorrow at 11 a.m. with Karim. I'm not sure if Karim is still here. With Karim starting the session tomorrow at 11. And for those who are attending the gala dinner tomorrow with the Zak Awards, looking forward to see you then tomorrow. Just bear with us if he is coming or not. I think, no, yeah, I thought so. Okay, so he is not coming. Thank you all for attending today. I'll see you tomorrow at 11 a.m. for the next session. Thank you. Join us on stage for the next talk. Karim is the design manager for Guardian Glass. Very excited for your talk.
Thank you.
Here's your clicker. Enjoy.
Thank you, Susanna, for the introduction. Lars, great presentation. Thank you for getting the wheels turning. Good morning, everyone. I'm Karim, by the way, and I work for Guardian, and we also produce glass in the region, just in case. If you guys don't know me or don't know Guardian, would like to know some more, we have a booth outside. We'd love to meet and chat. If you guys know me, it was lovely seeing all of you again. And if you kind of recognize the name but not sure about the look, it's probably because the last time I was here, I had a bit more hair on my head. Now the hair has migrated south. So let's see what the look, if I ever get called here again, what would the look be? Okay? So, Ahad yesterday, I'm not sure, I didn't see Ahad today. Ahad mentioned that they were doing something different with Zak this year, trying something new. And Guardian decided to play along. And that's why we, instead of a presentation, we decided to be telling a story today. Okay? So it's the story of a region and a dream and an ambition. Our story starts at the turn of the 20th century, mainly with the discovery of oil. So this region always had its people, it had big dreams, but oil, as it's also often referred to as fuel, was used to fuel this dream and this ambition. I can see the look on lots of your faces. We're not related by any way, and I'm not claiming that we are to any of these companies, but I wanted just to show you a sample of the dreams and the aspirations and the ambitions of the region. The region now is home to two of the biggest towers in the world. One is fully completed, and the other one is going to be completed soon, hopefully. The region is always is as well home to some of the giants on the aviation world, in the aviation world, in the oil and gas world, sports world as well now, financial firms, and so on and so forth. And the region also houses the biggest construction project currently ongoing in the world, and that's the NEOM and all of that construction site happening in Saudi Arabia. So Guardian was very early to identify the region and its ambitions, and it related to it by setting up a factory, a float line, in our Jubail plant in Saudi Arabia in 1996. It's been going there for a little bit less than 30 years. And at that plant, at the time, we produced float glass, so raw stock sheets of glass, mirror, so mirror glass, and patterned glass. Now, who amongst us doesn't know this project? Burj Khalifa. It's one of the most recognizable, if not the most recognizable, man-made architectural structure in the world. Standing tall at 828 meters. It was showcased in lots of movies, lots of shows. And it's the winner and the holder and the breaker of many records. So as we mentioned, it's the world's tallest building till date. It has the world's highest restaurant, standing at the 122nd floor. It has the world's longest travel distance for an elevator. And it's also the winner of the Leaf Award for 2010 as Best Structural Design. 2011, it won the Project of the Year from Mead, and so on and so forth. At the time, the designer for this project were SOM from Chicago. And the tower is glazed with about 174,000 square meters of coated glass, or roughly a little bit more than 28,000 panels of double-glazed units. Okay, now, at the time, the design intent and the architect selected our SunGuard Solar Silver 20 mixed with our ClimaGuard NLT to produce a multifunctional unit able to achieve the design requirements, the aesthetic intent behind the building, and basically achieve a reliable and continuous source of glass that met the requirements of the schedule for this project. Sorry. I'm really bad with tech, so. Anyway, it's not going back. OK. But imagine, 20 years ago, all of this glass had to be imported from abroad. OK? So Lars, you just mentioned all the reliability on local material. 174,000 square meters of glass had to be imported. Also, I want to there's a shout out to Yasmin Hodzic, who at the time, he's leading the marketing team in the region at the moment, but at the time he was part of the technical support team that kept on traveling back and forth from Europe to the region, meeting with the architects, the designers, the clients, to select the glass. As the region and the dreams became bigger and bigger, they decided to put titles and timelines on their visions. That's why we've seen the UAE vision in 2021. After that, it got changed or evolved into We, the UAE, in 2031, Saudi vision in 2030, the vision of Egypt 2030, the Bahrain vision of 2030, and so on and so forth. The building codes in the region also evolved, did not stay at a stalemate. They kept on evolving, improving, learning from previous experiences, making sure that the future designs would be more sustainable. So, Guardian, again, with the region growing, did not stay at a one float line. We kept on investing, we kept on believing in the region, and that's why we set up another float line in Cairo in Egypt in 2003, and then a third float line in the region in Rak in the UAE. And then in 2009, we got a coater that produces sputter coating in our factory in Ras Al Khaimah. And in 2015, we set up our regional office in Bahrain and Manama that's taking the lead on all of our operation in the region. Address Downtown. So this project was done by Atkins, was designed by Atkins. It is glazed with about 40,000 square meters of high-performance coated glass, and it was completed in September of 2008. So roughly around the same time that Burj Khalifa got completed. That's why the glass for it also was sourced from our European facilities, and we had to get it from Luxembourg. Okay, now, unfortunately, you all know that on New Year's Eve of 2015, 2016, there's a fire that broke out, and half of the building got damaged. Fortunately and thankfully to our local authorities, they were able to keep the human casualties at the low, but still more than 50% of the facade had to be replaced and was completely damaged. Now, at that time, we were producing HP Neutral 40 in our rack facility. So that's where we supplied the replacement glass for, and now the same building has the same type of glass. One is produced in Europe, the other is produced in Ras Al Khaimah, and the building is a living testament to the both types of glass looking identical. So the same glass, two different sources looking identical. Before, we could see it on reports, on data sheets, that they are the same. But here we have a live example in front of us of that building having two sources of glass looking exactly the same. This was our proof that what we were producing in the region is on par or equivalent to what we were producing abroad. Now again, with the region advancing, we did not sit on our hands. We kept on evolving and improving as well. In a bit, I'm going to talk about some of the improvements we've done in the region. So our technical support team, or what we at Guardian would like to call TAC, we had an Egypt hub that handled all of our TAC support for the entire region, Africa and Middle East. The old mentality or the old way of doing business was that this technical support would provide data sheets, project proposals, sometimes for buildings that are a little bit more complicated, some acoustic reports. But with time, we are now offering a range of new services solely from our Egypt hub. We are currently doing building energy calculations, overall glazing calculations, thermal full system calculations as well, in addition to offering advanced glass cladding consultation. And we also have worked or partnered up with a company called Fenestra Pro, and we are currently offering Guardian glass for BIM, for those of you who are using BIM. And let me see if I say this right. Our accredited LEED Green associates can offer you personalized solutions to help you get those extra LEED points if you guys are interested or if that goes into the scope of your design. So these are all the improvements and the new services that we are offering from our Egypt hub. Now, what we've done in the region was affecting the region as a whole, but starting 2022, the services that we are offering in the region were also used to support Europe and many parts of Asia as well. So the region is no longer the technical hub we have here, is one of the most advanced we have in the world, and that's why we are using it to also support many other geographical locations as well. The Select Optical Quality Program. Now, this is a program that we've developed with some of our partners in the business. Okay? If you look at some of the buildings on Sheikh Zayed Road, for example, you can see some visible distortion, or what architects sometimes call as wrinkled skin. So anytime you would approach the contractor or whoever it is, and you tell them that this is a look that's not acceptable for you, they would always refer you to the standards and tell you that what they have achieved, what they have made, is in accordance with the standards. We have developed our own standards. They are called the SOQ standards, but it's not just that we took the numbers divided by 2 or divided by 4, and that's it. We currently send Guardian personnel to the processing line if an SOQ project is specified, and they make sure that each panel that goes out of the facility has a barcode. If case anything goes wrong, you can trace it, go back to the tempering furnace, see what happened, what were the settings, what went wrong, and trace it. Okay? These are the standards that, if attached to any specification, will assure that this project will have a higher level of flatness. No tempered glass or no heat-treated glass is 100% flat, but this makes sure that the product or the buildings, the panels going onto the building are as flat as possible and definitely more pleasing aesthetically. In addition to that, we were not just happy by importing the expertise, the technologies that we are doing abroad. We kept on talking to our partners, to architects, to glass experts like you, and we kept on gathering feedback, seeing what the trends are, what are the new requirements, and we developed many products customized for this region, made in this region for this region. So basically, you talked and we listened. Now, these are some of the new innovations we've done. It's a gray-looking glass, but achieving a high level of neutrality with low reflection levels on the outside and on the inside. And the most important thing is that they are compliant with the building codes of the region. SN Gray 50 can be installed on a building that has a window-to-wall ratio of above 60% in Saudi Arabia, because it has an SHGC of 0.25. SN Gray 40 can be installed on a building that has the same window-to-wall ratio in Dubai, because it has a shading coefficient of below 0.25. And all of these are made 100% in the region. So, started in 1996. 2003, we added a float line, 7 as well, 1 in rack. Now we are present in 3 countries. In 2009, we added the smaller coater in rack. In 2015, the headquarters. 2016, that's where we added the big boy, the jumbo coater in our Jubail facility that can produce up to 8 million square meters of glass per year in all kinds of ranges, up to double silvers. Okay, and in 2022, the regional hub we have for technical support is currently in charge of Europe, AME, Africa, Middle East, Asia Pac as well. In addition to that, we were not just happy with setting up these factories. As most of you might know, a float line has a lifetime of about 20 to 25 years. It works 24/7, no Eid, no vacations, no holidays, no weekends, nothing. It keeps on producing glass. But every 20 to 25 years, it needs an overhaul. And last year, we completed our overhaul for the float line we have in Jubail, but we did not just maintain it. We added the capacity. We are producing currently 44% more glass there in a much more sustainable manner in sizes that are much more flexible. Okay, so time is almost up, and as we just mentioned, our story is far from being over, but we have to wrap up just because of the time. I will end it on a positive note. The region that was known to import technologies, products, expertise, and all, we had the pleasure of bidding for a project or working on a project a few years ago, which is the biggest infrastructure project in Northern America, and that's the REM Montreal Metro Station. And we are proud that today, the glass that is produced in Saudi Arabia, our SN50T, is currently glazing more than 50,000 square meters of facade on those metro stations. That was the first of many. We have currently a little bit less than a couple of dozens of projects in the US and in Europe. I'm just going to show you a quick other one, which is the Fulton Street, a tower in Brooklyn, New York, that's glazed with our DS Silver and the ClimaGuard Neutral 70 on the retail areas. And thank you. That's it. Thanks for the extra time.
Thank you very much, Karim. Guardian Glass is around for the entire day. If you're interested in anything else, please feel free to find them in the exhibition hall. Next, I'm very pleased to announce Kenzo Tamada, who is the area manager for Pellini. On blinds, I think, can't see if Lars is still here. I think he left, but I think it's like a great addition to what Lars told us this morning and giving us the insight of blinds and its sustainable approach.
Thank you so much. Good morning, everybody, ladies and gentlemen. I would say buongiorno because Pellini, first of all, it's an Italian company. We are based in Codogno, which is very famous because it was the first coronavirus-affected city. So that's a background that we have. First of all, Screenline is a name of integrated IGU blinds. So this is what we do. So basically, 2024 is a very important year because it's the 15th anniversary of the company activities that started from awnings production till 30 years ago. We started to invent something inside the glazing units. We have three different kind of divisions. So we have a Screenline, which is the blind inside the IGU. We have tender system, which is technical blind, so outside of the glass surface. And then we have some nautics, because we also have a small manufacturing, handmade wooden Venetian blinds as well. This is our group. So we have our plant based in Italy. Then we have a plant in Czech Republic, which we have, because we have a huge market in the UK market. And then we also have our glass processing company, which is actually, it's like a laboratory where it's very functional to develop and make tests on new products, like for now double skin facade, for higher glass panels, like 5-6 meters. So we do make tests. And what we do is sharing our expertise and new products together with our customers and worldwide partners. Idea Plastica is the last company joined us. Basically, is the supplier of plastic components for our blinds. This is very important achievement because we certify all our systems, which means components, blind, motor made by Pellini, inside a very specific environment, which is IGU. So we also use a very nice technology, high-end, which is the spacer bar with thermal break, which enhance more and more our performance inside the glazing unit. And these are our unique, let's say, the advantages of our company. So we have experiences, know-hows. We have more than 40 international patents on the systems. Pellini actually was the first inventor in the world about the blind inside the glazing unit. And of course, we also have all the leadership because we had the honor to start to develop the market with the highest design firms and facade engineering firms as well. So now I'm going to show, the time is not so much, so I'll try to give you some inputs so that later on we can maybe have a discussion together. This is how we can enforce much more on the shading and especially on the FC coefficient values to your project. Actually, what we do, first of all, is sharing our knowledges to everybody in order to make the project being positive as much as possible, because to my opinion, one project and one building is made for one target goal for everybody and work deal together. When usually we put blind inside the IGU cavity facade, the issue is the airspace gap, because usually when you go from 12 to 16 mm, the blind is very small. The glass surface has to be very, very small. So instead of it, we have to enlarge together with the spacer bar and thermal break to ensure thermal breaks. But actually, sometimes it occurs that the aluminum frame is very narrow, so we don't have to, we are not allowed to have enlargement on the glass panels. So what we do generally is to make lots of specifications, workshops, related information in order to, when you go into make developments and ensure that there is space enough for the shading as well. It's very important because we're talking about slats, aluminum, which are different colors, selected colors, because we make tests for anti-fogging, gas filling, and also high temperature performances. We have a structural, because eventually we are making more efforts in terms of energy saving for the facade itself. Thermal, because we also have dynamic simulation with Glass Advisor, which is our IPP, and it's a database of the glass products we put inside the blind, and then we simulate what is the target goals, starting from the U value of the facade and achieving the solar heat gain coefficient target. And of course, optical. So these are the general condition for the IGU performance indicators. So in this condition, this is a very standard one with a low coating. This is already in phase 3, but usually it's phase 2, doesn't matter. We start always from the U value. And then we see every time we analyze how the solar radiation works on a facade. So we always have this environment of reflection. And then we also have the secondary heating again, controlling inside, inside our rooms. And then we start from a G value. What we can do is, together with the shading, we can provide a shading factor, which is glass only or glass plus shading. So this is very important because everything comes from a concept of different analysis, starting from the light transmittance. So it's the way we select the kind of glazing our target goes. And of course, also the color rendering index is very important. Why the blind has to deal with it? Because the blind has some slats with the coloring specified. So the slats is part of facade. So once you integrate one fabric, one slats, it has to be chosen in the right way together with the glazing color selection as well. Structural. This is more general related to facade situations. So we, of course, always have three key points on window loads, barrier loads, and earthquakes. When we have on a facade, which is very difficult to integrate, but it's possible, nothing is impossible, we can also have outdoor shading, which is the high performance in terms of G values. But in case of earthquakes, raining, storm, or whatever, the blind has automatically be built up. The blind inside the cavity can allow you to be used in such conditions so that you can also enlarge more and more the impact on the end users inside the houses or inside your locations. In the structural analysis, it's very important for the blind analysis, also the facade orientation, the slope angle, and of course also the type of shading device, because the roller blind moves vertically. Venetian blind going on orientation and moving up and down. And also, of course, we also have this condition of shading color, which is very important, as I said before. Very quickly, we're talking about double glazing, very common, and we have the concentration on the U value, so it means transferring the heating condition, the criticized point, from winter time to summer times. This is a condition where we typically have three kinds of shading that we can develop. The first one is inside blind, together with the low-wick coated fabrics, and we can achieve a G value between 13 and 25%. The second one is outdoor shading. This is a Venetian blind, but could be also fabric for outdoor, like fiberglass and so on. We can achieve it till between 3 and 15%. This is the IGU unit inside with the screen line. So we have glass reflection, blind reflection, and of course we have convection of air and infrared coming from inside and going towards outside. We have two cases. We have TGU, between 10 and 12% in standard condition, but we also have one particular slats named the V95, which is a mill finish slats low-wick coated. So we can achieve such more performance using and selecting probably also some selective coating on phase 2. Low-wick coating basically is working on phase 3, because if it was in phase 2, the blind is getting more heating conditions. So we need blind to be part of a sustainable process. So let the blind first work and then have a low-wick coating on phase 3, unless there is also the chance to select on the project some selective coating on the phase 2. This is the case of selective coating on phase 2, so same condition, but the target goal with the DGU is between 9 and 11%. And mainly, this is a very nice picture that our partner glass processoring company decided to showcase this nice mock-up outside of the factory. If you can see, this is a transparent glass that is creating shadow. So you can imagine inside an environment offices or whatever it is, if you have, these are all the slats all down on 0 degrees, any kind of surface which is flat reflect what is their direct radiation on the surface. So we can enlarge more your lighting condition inside your room, inside your offices, and also let the illumination and also the LED situation inside work less. So this is a part of being sustainable. How is made an IGU together with the blind? Usually we have a spacer bar, very common one, but together with the blind, we have a customized part like angles, so we have caps already utilized so that the glass processory company already have the full kit to build. This is very important because we, in our environment, we have to guarantee everything to be filled inside and to be absolutely encapsulated and reduce the external activities to come in through inside this particular environment. So here we have a standard condition where we have the IGU specified, but I know that you guys are very probably knowledge more than me. In this case, we showcase how is reacting the Venetian blind and reflecting the light effect. So I don't know, maybe this one's not. Sorry. Anyway, it doesn't work. We have the light shelf effect, which is the consequence of reflecting the direct radiation. So in this case, we have a lighting on the top floor. When there is no blind, so glass only, we have direct radiation on the floor. So this means that environmentally, you have transparent glazing, so light transmittance, and then you can angle. The more you angle, the more you have privacy, and also you have less G value on your facade. This is another important case where we show specifically because we have two tests in a twin room where we have a selective glazing, 37%, and on the right side, same glazing plus V95 low-E coated slats. And one specific point, we have more or less 5 degrees of difference, just in one point. You can see how we can enlarge much more the direct radiation, and of course, we are talking about temperatures. This one is, of course, another bigger room where the direct radiation on the last row is very, very severe. So probably who is sitting on the last one is sweating. Eventually, the professor, the teacher, this is a room of the teaching room. In the teaching room, probably they have air conditioning, much more stress, and he's wearing such things to not to get cold. So in the same condition, we have different degrees, and the average is always 5 degrees of differences. So this is a part where shading can make performances more in terms of temperatures. This is what Pellini do in the area. So I am taking care about the Middle East area. Still, we don't have an office in here, but I'm building to be present in here. What I do is vertically to go to help specification, make training on glass processing company, train aluminum factory, because the supply chain is so long for us, for our products, that we have to guarantee that full IGU unit has to be known by every people and sometimes also by end users. So we also have different kind of systems. And we also have brushless system, which is a motor produced by Pellini. And different kind of product that you can manage by motorized and also manual system in order to also limit the end users to stress the blind or eventually to reduce at zero the maintenance costs. So hospital case with no system, or we can also use a sliding with magnets. Eventually, if it falls down, you can put it again with a magnet system. And we're talking about motorized system. What is the reliability? We have a certification by IFT body in Rosenheim, in Germany. We have certified 20,000 cycles for any kind of blind produced, and which means 3 cycles up and down and tilting operation for 20 years. Sometimes some people don't lower up and raise down the blind. They just tilt only, so the timing is much more longer. In terms of set accuracy, this is a screen line, so it's integrated inside the boxes inside the IGU. This motor has high accuracy, and we have more than on 1 square meter also 200,000 cycle certification with all the technical data, where we can show the temperature range working. It's between -20 and 90 degrees inside the IGU environment. This is the first case, which has 30 years, actually, which brushed motor. So we used to use our suppliers' motors today, blinds are 200. They're still working. We are just replacing some glass panels because 30 years ago, there were different technology on the glazing surface. I will go very quickly on the last pictures because I see the timing is over. This is in Italy. It's in Milano. It's a lowy facade where you see different colors. Where it's silver because it's angled 75 degrees, and where it's darker, actually it's 0 degree the slats. So let's say the G of glazing on 0 position of the slat is the same of the starting point. The more you orient the tilt the slats, the more you have G value performance. Some case, some residential case, some commercial, some facade on the corner where it's always difficult to put some shading inside on the corner, like curtains or whatever. With IGU, you can already solve this issue. And the last, not by least, we also have closed cavity facade system where we can put blind inside. And some other residential cases and facades. And this is Milano, where I live. We have shaded all the towers in City Life. This is specifically. Thank you for your attention.
Thank you, Kenzo. That was a very interesting journey. Before we go into the next break, we still have like one speaker lined up and a panel discussion after. So very happy to announce James O'Callaghan. Please, the stage is yours. We are very interested in what you're going to show us.
Thank you, Susanna. Do we have a presentation? Here we go. Good afternoon, everybody. It's a pleasure to be here. It's so nice to come and see all familiar faces and to be in this exchange of information, which is important for us all to be able to share what we do, what we know, in order that we as an industry can move forward and focus on those things that are important. As Susanna mentioned, I'm James O'Callaghan. I'm the co-founder of Eckersley O'Callaghan. We're engineers, just in context, primarily structural and building envelope engineers with some interest in specialisms around glass, which is to some extent what I'll be talking about today. But ultimately, it's about buildings, great architecture that inspires us, and solving those challenges in a sustainable way, and increasingly so. If I can click that, yeah. So we're now located globally. We're 20 years old last month. I know I'm a lot older than that. It's aged me, that's for sure. But in doing so, we've managed to spread ourselves around the world and have had the opportunity to work on some incredible projects with some incredible clients, and we continue to do that in doing so. And I think that working everywhere enriches us culturally. It enriches us in terms of our technical acumen, in terms of what we learn from what we're doing in different places from different people. And that's why being in a place like Dubai is important, because understanding how things are done in different environments is key to the success of how we do things everywhere. In terms of our approach, I suppose the sort of distilling the three things that we mix into our workflow, touch every project that we do, is really the combination of these things. Sustainability, research and development has been very much a core of our engineering approach, and applying that in parallel to continuing research through our projects. And through that is where we hope to hit a sweet spot of innovation, for which some of our projects, I think, have been recognized as. I'm going to start here, because I think that this is partly a reflection over the work we've done in the last 20 years that I'm going to talk about today, and partly about where I see things changing and where perhaps some examples of projects where we've hopefully been able to weave in some of that future narrative into the solutions. But let's start here. This is the mid-1850s. Early 1850s, 1840, Joseph Paxton, very famous Chatsworth House greenhouse. And what was important about this building, I suppose, in terms of what I would like to talk about in the narrative, is that this was at the point, recognizing the Industrial Revolution at the time, and it was how glass could be used in a different fashion. Of course, it had been used in buildings before to create windows, etc., but now it was kind of in this combination of this time of great optimism and industrialization, that combining these materials and finding ways in which materials could be used in more effective ways. And the result of this, of course, is this beautiful piece of architecture which, you know, has a function of letting in light, but it has a beauty and a filigree nature that kind of era was able to inspire. And I look at it and think, well, okay, where have we come from then, and where are we likely to go? What does the current technological revolution, for example, that we're in right now, how is it going to affect what we do, and how does it address the sustainability narrative that clearly is a part of what we must do collectively to be more responsible about how we build things? So in my own little time frame, in the 20 years that I've been working with glass, it kind of really started for me around this time. This was the latest and greatest technology from Apple at the time in 2000, at the turn of the millennium. Just after that, if you remember, 1,000 songs in your pockets. Who could ever imagine technology being so great? Of course, I'm being facetious, given that we now have 1 million phones in our tunes in our pocket, and we can use that device to do everything we want to do. But at that point, you know, going back to that point about Paxton and his ability to embrace what was then the Industrial Revolution, of course, we've since then had many things. The invention of the float glass, for example, in the late 50s, pretty pivotal to our ability to be able to industrialize glass and the creation of the modernism movement. But this work that I was doing for Apple, with many partners and many great people in this room that, you know, that have been a part of that, the architects we've worked with, the engineers, the fabricators, the makers, all of which have participated in making some of these moves. I think at this point was about how we could drive forward a material in terms of transparency. Now, of course, we had the benefit of a great funder, we had a mission, we had a clarity around what we wanted to do, and we had the runway and the trust of our client to be able to take that forward in this way. And with that sort of combination of ingredients, we were able to really shift glass in that period of time through for it to be able to do many things that we now take for granted. Using, you know, materials such as the advent of Century Glass allowed us to be more ambitious about the way in which we supported glass structures, carried people, spanned it further, combined it with new and old architecture, developing fittings that were reducing in size and taking and having more function, but continuously looking at the materials themselves to get more out of them and out of their combination to do more. And I think that is an important part of what we must do collectively, get more out of what we have. Whether, you know, the less material we can use, the more ultimately sustainable our buildings become. So the more that we can think about building envelope, for example, in this context, and how that can compress to be able to do more in terms of its function operationally, but also in terms of its actual quantity of materiality. So this was not at all in any way an exercise in these early days about finding a sustainable solution, but the narrative that it leads to about being able to do more with less is something that I've carried from this experience through into the work that we do now, and it's where I'm interested in research in the future. So, you know, it was a journey. It continued through greater step-by-step development of details of materials, of understanding, having more trust in the materials and their behavior, being able to push it each time a little bit further, project by project, innovation by innovation, and that, of course, in itself created an architecture and a nature to some of these projects. And of course, it never stopped. It just evolved over time. And it evolved from, you know, simple staircases and developments around that into buildings. Those buildings, in fact, involved themselves or evolved and became less, you know, not the most sustainable story I have, to replace one building with another one that's exactly the same, and there was nothing wrong with the first one. But it does at least represent a development of that understanding about technology and how you can do more with less, in a way, more transparency, greater, more reliability on every individual piece, being able to integrate things in a way that that made things more sinuous, more from an engineering perspective, more integrated, and having that sort of ability to then translate that into something that changed the architectural diagram, and also the way in which it was functioning. A sort of maniacal focus towards transparency, which, you know, that was the goal. It wasn't at this point about energy for these particular buildings. It was about a structural approach to transparency. And therefore, in order to get more transparency, it was about taking things away and getting the glass to do more and the things that connect it together to do less. And that, I think, is key. Now, this is an example of a project where you could almost call it a folly, really. I mean, it was where can you take that discussion? Where can you get to the point where you create a building that just has 5 surfaces? I mean, it's a generic square, but how do you do that? Well, it's actually quite difficult to do it all in glass, particularly when the roof is made out of glass because of gravity and the requirements that you would need to stiffen it and strengthen it. So stepping beyond one material into the realms of another material and starting to look at composites and seeing how composites themselves could perhaps be integrated with glass. They can do, you know, they clearly don't have transparency, but they have the ability to do things that glass didn't. And then you start to think about, well, how do I use materials for the right function? You know, don't use the glass if the glass isn't going to be the right material for this particular structural approach. How about other materials, be it, in this case, composites? But of course, I'll talk about other materials where we've chosen the material discussion around its best function, and ultimately now around that discussion around sustainability, those materials being important. And Lars talked about that a little bit earlier, and what those important discussions about what sustainability is and longevity. So you end up with this kind of simple idea of 5 surfaces, a literally impossibly thin structure. So there's no structure apparently, despite it winning the Structural Engineering of the Year award for not having any structure. So you sort of have this journey of experimenting and fortunately having the area in which to do that. But what's important about it is it then obviously informs other architecture. It has another engineering and other solutions. These things spin off and find their place in different areas of work and our building industry and our building solutions. And of course, that is progress, right? That's what progress represents, and it's important that we all have that kind of philosophy that everything we do hopefully has a future in a wider context of what we build when it's a good idea or a useful idea. That particular example then got extended to this project for Apple, which of course is their Theatre, now named after Steve Jobs, which is where they essentially launch all of their products and marketing events whenever they have a new iPhone, etc. But it really was about pulling together this composite theory, extending it. How far can we push it? In this instance, to a sort of 60-meter diameter composite dome built by our friends at Premier Composites. In fact, this was made not far from here, this roof, and then assembled on site in, there we go, there's a photograph of Premier Composites yard it being made. 44 pizza-shaped wedge bits of composite, which were then taken to California and assembled on site and then lifted into place. And here this video kind of neatly shows its, again, its incredible efficiency in terms of its depth and span ratio, resulting in something that ultimately has a purity to it in its simplicity, both in the transparency horizontally, but also in the simplicity of what that structure becomes. Now, moving a bit forward, this project was recently sort of completed during COVID, and I guess completed a year or two ago now. But it's a sort of response to the fact that you need to take, these the energy requirements to make these buildings work now are clearly significantly more stringent, and responsibly one has to respond to that. So this is a sort of, it's a glass structure, but it combines other opacity to it in order to be able to get that that environment. And of course, it enriches the environment in many ways. It creates this kind of quite interesting contextual space where light is much more diffused, it's much more controlled, and yet it still has this beautiful glass skin. The panels themselves are actually all they're supported vertically on these very, very slender, you can just about see these very, very slender black columns. The columns are 100 millimeters by 50 millimeters, and the whole dome is 36 meters in diameter. So you can imagine that these little spider legs would have no ability to be able to support the weight of this big glass dome. So the glass panels are actually stitched together and locked into each other and locked into these vertical columns or these curved columns in order to brace them and keep them in place. So that's how this sort of, again, this integration of using the materials. We're not building a structure and then putting glass on it. We're building a glass and structure that works together, therefore resulting in less material to achieve the same dome structure. And of course, at the same time, you maximize where you want it, that transparency, because you're not using an over amount of steel to support amount of glass. It's an intelligent combination of it, resulting in, ultimately what you wanted in terms of that transparency. And whilst this is a folly, clearly, it is a swimming pool spanning between two buildings, and it's not made out of glass. We looked at making that out of glass. That's how it started life, and decided to ourselves that actually that was the wrong material to make it out of, for lots of reasons I've explained before about connectivity and the limitations that glass has in terms of that connectivity. And the structural limitations of its weakness around its connectivity, and actually opted in this instance to make it from acrylic. It supports 150 tons of glass spanning between two buildings. Those buildings are, and the bearings at either end of that articulate to allow these buildings to move relative to one another. That's now been there 3 years. Again, it's a sort of experimentation of, if you're going to do this, which is a questionable thing in the first place, but if you're going to do that, then what's the right solution for it? And I think that's key. So let's shift gears a little bit and talk about the challenges we're faced today in terms of engineering. And this, of course, we're right in the place where perhaps some of the effects of what we're seeing in climate change were demonstrated last week. But we all known about it. It's well publicized. We don't need to really we don't need to question that in terms of what it does. But what's important for us is what we do about that. 40% of emissions is as a result of our industry. And then if you drill that down into the building envelope, then a significant portion of that comes down to what we wrap our skin of our buildings in. Now, the industry responds to that in many ways. Codes respond to that by saying, okay, less energy should go through, less solar gain, less thermal, higher thermal performance where necessary needs to happen. Therefore, what we'll do is we'll play with the window wall ratio. We'll reduce the amount of glass that's permitted by having a baseline window wall ratio that's lower, and that results in us using less glass. And glass is getting a pretty bad rap, right? I mean, there's lots of headlines as we see here. And what's its future? So us in the facade industry, if we want glass to remain relevant, we have to be creative, very creative, about how that glass will be used in the future and how we adapt how its technology of it adopts the solutions that we provide, change and evolve in order to make it relevant. Because at the end of the day, we love our glass and we love our light. And our balance between light and energy is the battlefield on which we all sit. And we've seen it today, the last few presentations from Pellini, etc. It's about the balance of these things. And what does the current revolution in technology and the current revolution in our sustainable thinking result in? How do these products evolve? We are in the most concentrated period of innovation necessary in order to solve this much greater agenda of climate change. We know, my little discussion about transparency was in a commercialized world. We're now in a much more different set of priorities. We want our light, and we don't really want to live like this, I imagine. This isn't our future. It's somewhat dystopian to look at this image, to have less and less glass. And of course, it doesn't really help the industry if we have less and less glass. So, how's glass going to play into our future? I like this image. It's Singapore, actually, but if you look to the right, that's kind of where we were in the 70s and 80s, and you'll notice that the sort of window wall ratio is such that our codes would like us to kind of be over there right now, and perhaps even less and less, to the point where our windows diminish completely. But in that time, we went through this kind of, the green phase that we all knew about, when that was the coating of choice, in towards the more neutral coatings that we now see. And of course, Guardian have just been showing us some very nice examples of their neutral coatings to deal with high performance glazing. But it's, as a reminder, we like this sort of 70% window wall ratio. It ultimately, this is a building we finished in Hong Kong recently with 3 meter wide unitized panels. And you can see you get this great transparency. Another building we recently finished with less transparency, but that's the kind of drive towards where one might be. And this is, in fact, a new building in Sweden with a 33% window wall ratio, because that is what the code was determining it to do in order to maintain the transparency and the clarity in the glass without having particularly high-performing glass or particularly dark glass. Then that's where we end up. So what are we going to do? This is the sort of comparison of these things. What's the result? We obviously have to make our facade work harder, and there are ways in which we do that. We all know that there's static methods, glazing, coatings. There is translucency, which again, it starts to play with that idea of transparency and how we feel about that environment. There's shading, again, a sort of static idea, all of which are possible, but perhaps not that adaptive. They don't relate to the changing climate that they're in. They sort of solve a worst case problem and then they're always there, which is fine. This particular building across the road here that we worked on attempts to sort of deal with that somewhat dynamically in terms of shading. And we can optimize that shading to some extent because we now have the tools, obviously, to be able to understand when it should work best and what orientation of the facade might be able to adopt that best. And we can combine that with thinking about materials, using more sustainable materials, perhaps, and integrating those more into our building envelopes and our building structures, which we've seen in the revolution of more timber buildings, more mass timber buildings. And we're beginning to see significant interest in more timber-type facade typologies too. And then you start to move in things that begin to be more intelligent, like systems, where technology starts to adapt the facade, be it through closed cavity facades, which Lars talked about with as a comparison to the ACT facade that Predominant developed. But at the end of the day, it's finding ways for the systems within other systems combined with the facade to be able to better manage the interface of energy. And the closed cavity facades we're seeing significant interest in, despite the fact they're clearly more costly, and I don't think they're the answer particularly to our future, but they do at least allow us to have more glass, more transparency when we want it, less demand on the static coating, so we're not making our buildings particularly dark. To deal with those worst case scenarios, we have the ability to adapt them. So it's important. They're finding their way into industry because they solve part of this window wall energy relationship. Less darker and darker glass, and it has a way to do that. And we're seeing it in London, Sydney, and Germany, and Switzerland, etc. These places that are seeing it more. Not so much here, but in time, I suspect we'll see more of that as we get to the point where the demands of the codes put more on the glass. Biophilia, as Lars points out, needs to be done in the right place, but it is part of something that's in the mix. Dynamic glazing, it's in its relative infancy, maturity perhaps, and I suspect we'll see much more out of what that'll be, how it works, the variations, the opportunities, how that then combines with artificial intelligence, so it reacts to user comfort, which of course is super important. How you're feeling in the building is as important as how it might look or what it is. It's what's your experience of it, and perhaps your connection of your emotions and experience should be tied to what that facade is doing to an extent. So this is some research that we are doing at TU Delft, which looks into that, combined with sustainable solutions. And I think the environmental impact of, this is a report from Arup, which I find quite useful, is a sort of indication of the kind of carbon footprint that any one of our particular wall systems are looking at, the procurement of facades, where they're coming from, how clean is the energy, how far is it being shipped, all has a quite significant influence on the actual embodied carbon that we see within those things. We've developed a series of tools, one of which is this one, which is a plug into Revit. So here's a plug into you. If you want to take that note of that, please write to us. We distribute that Revit plugin, which will monitor and count lifetime all of your embodied carbon in any structure or facade. So, and it's a free software. So please, by all means, the more we can share it, the better. I've just got 2 case studies to go through quickly because I have 7 minutes left. And this is Atlassian. I think this is important for us because it was an opportunity again. I can't underestimate the importance of having clients behind you that want to do things, to innovate, to change things. This particular client was very keen, is a very keen environmentalist. They are a software company. They make software for software engineers. I didn't know much about them, but they're a multi-billion-dollar company globally, based originally in Australia, now obviously everywhere. But they wanted to build a new headquarters as to attract talent from in Sydney, software talent that was graduating and not just getting on a plane and going to California to work for Apple or Google or whoever, but to remain and sort of build a sort of technology center within the middle of Sydney. So this is sort of building is the sort of flagship of that environment. But the brief to us was, in fact, to build a building, it's a tower, 200-meter tower, but build it with 50% less embodied carbon than you would do if you were to build it out of the traditional methods, so with concrete, steel, whatever. So find ways to do that. 50% less operational carbon and 100% renewables. Now, that's quite a tall order if you're going to build a tall building. And so we had to look at ways of doing that. And from a structure perspective, we came up with this concept of using timber. Clearly, you can't build a timber tower that's 200 meters tall for lots of reasons. The columns, for a start, would be very big, probably about as big as the building. And so we broke it down and said, well, okay, what's the maximum height timber building you can build in Sydney without going to performance engineering? And it turns out to be 25 meters. So why don't we take 25-meter timber buildings and put them in a bookshelf on separated steel floors as a concept? A little crazy, probably because we don't build a lot of towers that we had that idea, but sometimes naivety is the mother of invention, and that perhaps was our case here. We then put this idea out to an international design competition. 5 architects then submitted these 5 designs, the winner of which was Shop. They adopted our concept as a structure, slightly modified by having an exoskeleton on the outside as opposed to internal columns, but it essentially has these timber habitats that sit within these steel floors, and you can just about see from this image here. And this is that final structure solution that we then work through into detailed design and is now in construction. And by doing so, by taking the majority of the volumetric material and changing it to timber from concrete or steel, despite the fact that it's still a kind of steel building with timber habitats, you end up with a significantly lower embodied carbon or impact to the building itself. So it's a smart way to solve a fairly standard problem. It creates these environments, it creates these habitats, it creates these spaces which can then be internal, external within the tower, all wrapped within a naturally ventilated facade system that allows that space to breathe. Again, this is an environment, Sydney, where you can do that kind of thing. It's not the same for every environment, clearly, particularly here, for example. But it allows you to have this kind of, you're using the environment, you're using the place to massively inform how that building can be architecturally, how the people can experience it, what their user comfort will be, and making the most out of doing so. And there's quite a lot in how we looked at the facade in terms of its generation of electricity, its form, the materiality of it, its ventilation, its combination with the mixed mode of those internal timber spaces. It's geometrically quite complex. As I say, it creates these kind of horizontal shelves, all of which, all the way up the building, allow us to generate solar energy from what they pick up. Google, a number of buildings we've done with Google, but I show this one because it's a relatively straightforward building, but in terms of its materiality and how it might influence buildings that we do in the future, I think it's important. It's an entirely mass timber building, and it has a closed cavity facade, which is an aluminium system with timber Venetian blinds. So there's a large amount, again, of organic bio-based material in this building. It uses the closed cavity facade to moderate the energy, keeps the glass relatively clear in doing so, in doing so allows us to have quite clear glass in what is obviously a relatively high solar gain environment. It has bird frit on it, which is what you see there on the left-hand side. This was the first closed cavity, this was finished a year ago. This is the first closed cavity facade in North America, and there's a couple more now that are underway, and one or two being completed in MIT, but I think they represent a growing trend of how you can then build in a relatively high solar environment buildings that have relatively clear facades and a system that can adapt to create and moderate that light and shade and glare that you experience within the building itself. This building is particularly important because it's an example of this area D, where I think we need to be doing an awful lot more about when we are developing facade systems about what their end of life might be. And there's lots of work going on by many of you in this area, both in recycling, in reuse. But this is specifically about how we design things to be reused and what approach should we be taking. And I like it because this is a building designed in 1965 by Jean Prouvé for UNESCO. And in 1965, he designed this facade, 1969, sorry, he designed this facade to be taken apart and refurbished in 50 years' time. So that time is now. So 2 years ago, the facade was failing. I mean, clearly it got single glazing, the gaskets were failing, etc., but it was 50 years old. So rather than tear the building down or rip the facade off and build something new, we were able to actually go into this building, take it apart, panel by panel, change its inner structure, which we then changed to a timber inner structure to reduce its any implications of adding more aluminium to it. Replaced that in doing so. Cleaned the whole thing up. This is an example of what it was looking like. Protected its environment. We recycled all of the glass and rebuilt it with this timber core after cleaning. And in doing so, it was a massive. This is a diagram of what one would do if you had an aluminium core in it versus a timber core in it, so we could significantly reduce what the implications of any additional embodied carbon would be. We'll be clearly recycling the whole or refurbishing the whole building has very, very low embodied carbon. All of the glass Saint-Gobain recycled as part of their pilot programs to get more of the waste glass that they're collecting from buildings throughout the UK, France, and beyond. The same in Holland, and being able to get more of that into the mix. So that's an ongoing process from all the float manufacturers about ways in which they can get more of this recycled glass. As you know, the recycled glass in the building industry is less than 5% of all glass from wasted glass on buildings goes into recycling, which is a criminal thing, given that more than 90% goes into making container and bottles. So we've got a lot of work to do there, but this is a great example of what happens when you do it, right? And if you thought about it in the beginning of how you put it together, when you can put it back together and you get from that to that, and you end up with from the left to the right, and it's got another 50 years left in it. It's now got double glazing, it's got high performance coating in it, transparency, and it's a beautiful example of what we can all do when we put our minds to it about how we can be responsible for our buildings. So thanks to Jean Prouvé for that idea. We should all do more of it. So thanks very much indeed for that whirlwind of everything.
Thank you very much, James. So adding to that, I think James gave us the right introduction into our panel discussion. So if I may invite Marina, Johan, and Salah, and myself on stage to get prepared for our panel discussion.
Good afternoon, everyone. So, Susanna, you have already done some introductions, but let me just go one by one so you all know who is today in the panel. So we have Salam here. Salam is the Assistant Manager of Sustainability and CSR at Masdar. We have Susanna. Susanna, everyone knows, she's been introducing absolutely everyone in the past 2 days, but I think it's time for me to introduce you. Susanna is the Head of Facade Engineer at WSP. And then we have Johan, the Associate Design Leader at Woodsbagot. So it's really good, and the whole idea of this panel is to have the different stakeholders here. We have the consultant, the developer, and the architect here to discuss about what we consider truly sustainable facades. And as Susanna said, James had a really good presentation that is kind of really helpful for the panel that we are going to have now. So,
yeah,
James,
I totally agree.
James, I can't see you, but it was amazing. Thank you very much. So if we start, I would like to start asking you more on a view of your company. So I would like to start with you, Salam, because Masdar is well known in the market and even internationally because Masdar pushes the limits and they always go above the minimum targets. So I would like to understand what is Masdar's current position in response to the global targets of carbon reduction, and what are the specific targets?
Thank you for this question. At Masdar City, we are tackling one of the major contributors to the global carbon emission, the built environment. We are creating a global reference point for the cities who want to be part of the sustainable solution for climate change. We are committed to achieve net zero emission by 2050. We have one of the largest clusters for LEED Platinum buildings. Also, we have 5 net zero energy buildings, 2 under operation, 2 under construction, and recently we launched the first net zero energy mosque in the region.
That's quite impressive, as we all know. That is not common, and I think is something to value. It's amazing that some of the developers are pushing above the targets or what is at the moment being pushed in the market. So I would like to hear from you, Susanna. Mm-hmm. Susanna, what WSP is currently doing in terms of what are the targets? Because being a global company, I'm pretty sure that you guys have some internal policies and targets.
Yeah, we do actually. So here within the region, we do have a dedicated team within the organization, which we call Future Ready. So their target and their plan is to make sure that all the other disciplines within WSP, it's not just facades, it's MEP, it's structures, it's everyone who is involved in the building construction process to start thinking net zero when it comes to embodied carbon in materials, operational. So that dedicated team is there for the organization as an initiative. And within our facades engineering team, we do have our champions, which we call them, who are part of that overall organization, who are leading the net zero approach. Yeah.
That's impressive. Johan, in Woodsbagot, what is the approach that is taken at the moment?
Thanks, Marina. Woodsbagot have deployed as a global practice a significant effort in terms of sustainability by regrouping a series of professionals across our 16 studios called the Global Impact Group. So this came along with our climate playbook publication that also sort of outlined all the different commitments that Woodsbagot has done. Notably Architect 2030, Architects Declare, UN Sustainable Goals, Greenhouse Protocol, and it's all sort of detailed in that playbook and also involved in each and every project that we are involved in.
That's interesting, and so I can see how, of course, from the developer point of view, but from more the engineer part of the project, I can see how your companies are pushing for that. But I would like to know, taking in account and going more focused on the facade, taking in account the influence of the facade on embodied carbon and operational carbon, I want to know what is the approach that you take. And I'm going to Susanna now because as a facade consultant, I want to ask her directly. I will jump to Johan later. But Susanna, what do you do to try to reduce or to reduce the carbon emissions through the design? What are kind of your key
So while we are pushing always beyond standard requirements, whatever is in the local codes, we always try to educate and raise the awareness within the entire project team and the clients, of course, that the better you push towards higher standards and higher values, whatever is the minimum requirement, the better is your operational and or your embodied carbon. But what we face as a challenge, I would want to say, is it always depends on who is your client and what is the target and the approach of the client. If you're, as Mazda, I think, is doing it in most of their projects, they're also operating, right? So it's easier, and I think we're all on the same page as long as the client is operating itself, or if they're selling it off, because then it's kind of the interest of reducing it is not there anymore. So we are always trying to find the balance of here is the minimum requirements, but we are showing you the benefit of what it means to go beyond those minimum requirements which are set by the government.
So we can say that in a way you are trying to, with the whole technical team, to not educate but to inform, to help the client to take informed decisions in terms of towards more sustainable materials or reducing carbon footprint.
I think it's an educational process, right, where we as engineers more than anyone else have it in our kind of leaving it in our legacy to raise the awareness to architects and developers of what it actually means, not just from a performance but also from a commercial side, right? Because that's always the big discussion. And better performing building envelopes or better performing buildings doesn't necessarily always mean that it's more expensive. Right? And I think that education or that raising the awareness is coming from us more than anyone else. Yeah.
Yeah, and Johan, as an architect, I'm pretty sure, because Susanna, she takes the data, she takes all the numbers, and she comes to the client saying this is more sustainable. But I'm pretty sure, as an architect, this discussion is slightly more difficult because you need to fight for both things, the sustainability plus the aesthetics. So I would like to hear, how is your approach? Because I know that Woodsbagot approach the design towards sustainability.
You're right to say we tend to get carried away sometimes or excited. But so what we did, we've established a protocol called the Global Impact Assessment, which basically split our project and every single new project into 60 metrics spread across 12 categories. And it goes from the site to the building, architecture and design, all the way to occupation. So by doing this, and over our 16 studio, we're able to sort of appreciate or quantify how we perform and make sure that we're on target. Because it's good to, those pledge and those commitments are good, but you have to keep track of it. And it's very organic because there's so many metrics that comes into play. So we developed our own tool and we keep it extremely transparent with our clients so that the end decisions is in agreement with both design, but also all the different constraints that we face when building architecture and engineering.
So if I can go more in detail in terms of what are the challenges that you face when you design a sustainable facade, and then you need to, it's not a challenge, it's more about what is the rejection from the client, what is the concerns of the client when you mention or when you design something that is kind of, or you would say that is more sustainable?
I mean, sustainability is welcome, and we don't really receive, or we rarely receive brief without sustainability targets nowadays, thankfully, which is great. But when it comes to, the sort of associated cost, there's always that little apprehension when it's an issue or it can be an issue. So again, we use our tool to keep it very transparent. So we run daylight analysis, glare analysis, natural light analysis, and we show the before and after. Before we get excited with material, before we get excited with the subjective part of design, we make sure that the facade and the building skin perform, and that if components have to be taken away, we can rerun those analyses, and for the client it is clear Now, embodied carbon is another challenge, though, because it's a bit more difficult to appreciate, mostly because suppliers don't always provide the information. And what is embodied carbon? Is it starting with the energy and how the energy was produced for the actual fabrication? Or is it just about taking the material and transporting it? So I think there's a lot of progress that has to be made on the embodied, but with sustainable and performance, I think we use our tool and we keep it very transparent. Yeah.
Good to hear. I think it's the same approach for all. It's as far as you can prove, as far as you can go transparent, show the data, it always helps to kind of guide the whole design. So that was more for the engineer part, design part of the panelists. But now it's going to be a question directly to you. I wanted to understand from developers' point of view, I wanted to know any notable example where the facade performance was analyzed in detail and to reduce the overall carbon footprint. Masdar, I'm pretty sure, as Masdar, will have a lot of good examples. So I would like to hear one in detail, and if you can explain to everyone what were the key drivers to make this project successful, it would be great.
That's a good question. At Masdar City, we care a lot about our facades. They play for us multiple roles. The first role is a social role because it allows us to protect and also maintain the privacy of the tenants. The second role is an economical role because it allows us to, by using sustainable design, choose the right size of the window, the right size of the shading devices, the right type of materials. It allows us to have a lot of savings in terms of energy. And this simple exercise has magical impact. We have multiple examples, and I would like to choose MC Square building because we have 3 of us work together to make that happen. That will be a LEED Platinum, WELL Gold, a net zero energy project, and also the home of the energy department of Abu Dhabi. We are proud to say that we collaborated together in a very magical way to make it happen. Remember during the meeting, the first meeting with Case One and our design team, a simple idea of clock turned out to be a magical building, a net zero building, and the home of the net zero energy headquarters of energy department of Abu Dhabi. How we did it? By collaborating together, by choosing the right people to collaborate with, choose the right type of materials, the right type of windows, the right size, the right orientation to reduce the energy consumption. Then later on, we use active design strategies and then top up with the renewable energy. That's the magical formula behind everything, which is collaboration and choose the right partners.
I think that's, I couldn't agree more. I think, not because I have worked on that project, but in general, I think it's just the magical world is collaboration. But I think there is one important thing. Not all the developers, not all the clients are like Masdar, that they want to push the limits. Yes. So I think then the government plays a really special role in this one. We need government to push for more stringent targets, push for reducing carbon footprint of what we design, because this way is not an option. Everyone will need to push for that. So then I'm going to go with a more specific question in that regard, and I will start with you, Susanna. Mm-hmm. I want to hear everyone, but it's based on your experience. Do you see a shift in UAE towards reducing the overall carbon footprint, or still its focus is primarily on operational carbon? Based on your experience, what you are finding?
So we do certainly see the trend in discussing it, and it's always on the table. It's always like a big word. I mean, sustainability, I think it has its glamorous time when everyone was talking about sustainability in the past years, and now it's like net zero as the next goal. And the trend in the UAE, or what we see coming more and more, is yes, we do want that, but as I said, it's like a very to close the gap in between what it actually means and what are all the cost associated to that? What is the impact, the appreciation, as Johan said it, right? I think that's the right word to label it, as you can't really appreciate it because you don't see it, right? Yeah. And that's a discussion. It's there, at least in the UAE. Our global offices around the world, obviously, the markets are like more mature. The government is pushing for that and is standing behind that. And hopefully soon, we will see the shift in the UAE as well. We have COP28. We have targets within the UAE or the region. Saudi, I think, is pioneering this at the moment with a lot of project requirements which are coming back to us to be net zero or highly sustainable. So it's a trend. It's a trend in discussing, but yet to push for it, I think it will need a little bit more time.
I mean, it takes time. These type of things, it takes time. As you mentioned, it will have a cost impact somehow, so it takes time to take these proper policies in place. Mm-hmm. Johan, are you facing similar things that Susanna? Or?
Well, I mean, I think it's not too bad, meaning that we see an interest, and of course it could be better, especially for embodied carbon, which is a bit ignored in a way, for the jack of all trades. But I think we can already, as architect, design smart without necessarily having to have regulation that put us in that sort of challenging situation. Masdar is a great example. By going back to the basics, so, you're designing in the Middle East, the vernacular way that things were done before. Masdar, we actually had setbacks every floor so that the facade would be self-shaded. It's easy. It's been done for thousands of years. So I think although we have to meet those requirements, there's already a sort of window that can be achieved towards design and basic. Sometimes I think we go a bit too far into performative skin while we're missing the basics. That I really encourage young architects and designers to go back to where do you design and what's been done in the history of the country to achieve a sustainable building.
Can I add to that? Sorry,
sure, please.
Just a thought. I think Lars said it in his presentation this morning that the awareness, actually I think it's the awareness of architects, international architects coming into the region, that they don't understand the climate, right? And as Johan is saying it, right, I mean, you don't have to be like ultra high performing and having the latest standards. You just gotta have to understand what and for who you were building it. No? And I think Lars said it right in his presentation this morning. Understanding what you're building for is key, I think, yeah.
I think it's a really good point. I think we can see the shift slowly and slowly. I think there was a trend 10 years ago that the architects were pushing, or the design team was pushing for more like an iconic solutions in terms of the buildings. Now there is a shift on looking more to respond to the local requirements, to make a building that actually is designed to be there, not anywhere else in the world, which at the end normally usually make it more sustainable because it's been designed for the purpose. So I have seen also the shift in that. On the projects that we get involved is more and more related to the local and climatic conditions.
If you allow me just one point to build up on what you said, we care a lot about embodied carbon. Since the very inception, the very first day during the creation of Masdar City, since that date, we started tracking our embodied carbon and try to reduce it project by project. 2022, we had an embodied carbon over all our portfolio of 642 kilograms per square meter. That number is going further down. Our target for 2030 will be something around 500. And by by 2025, it will be something around 550, and by 2030, we are targeting to achieve 400. How we are doing it? We are doing it by choosing the right design, the right type of materials.
I have a question then in that line, because you have now explained the reduction, the carbon reduction in the design, and we tend to face a little bit as designers. Sometimes we tend to face that. How can I say it? A lot of times, being able to design a facade that is more sustainable, it's mainly applies to the reduction of the window wall ratio, for example. And a lot of the clients says that, okay, yeah, but how my office building is going to have now a 50% window wall ratio, like how I'm going to sell this space, what everyone, all the tenants wants is the full view of the glazing. And Mazda actually is not that keen on that one. Of course, the internal space is crucial for you, and based on what I have seen, is really comfortable internal space. But I want to see if you are seeing that the people would rather rent another type of offices because they have the full view, or they appreciate the amount of effort that Mazda does in terms of reducing the energy consumption, for example, in this case.
That's a good question. I'd like to share with you the story of one of our prestigious tenants. He moved recently to Mazda City, and he did a simple exercise. He compared his utility bills before and after moving to Mazda City Free Zone. He did also a survey for the happiness and the performance improvement of his employees. And the results were magical, because his utility bill is reduced, water, electricity, and cooling. And the results of the survey shows that the employees are happy, comfortable, well connected to their colleagues and friends outside, which is very important for us. We are glad to hear that, and we are glad to see him joining our race against climate change.
Okay.
And if I may, by the way, when we were designing Mazda, so we were aware we would have to respect somewhere like a 60 to 40% ratio of window to wall, but we were also aware that usually tenants want to have floor-to-ceiling glazing, right? So we started designing this sawtooth facade by putting one vision glass, one solid panel. So in the design embedded, we were already at 60%, 40%, and no one ever thought it was a flaw or a need. They thought this is the identity of the architecture. We see it from outside, and we experience it from inside. So it was embedded from the early days, let's say, but not an afterthought. Right? And I'm glad to hear that everyone's happy.
Yeah, thank you.
So, and now I'm going to go to ask you, because we've been talking about based on your companies, what are the targets? A little bit on your projects are your approach, and of course, as a developer, what are the key targets? And then the UAE current targets. I think I want to know from each of you, and I can start with you, Susanna, again, because it's more specific for just the facade. I want to know what is your vision for a truly sustainable facade. So. You, as an engineer, as an expert of facades, how do you see the future of what we call it? I think we all talk about sustainable facades. Everyone puts the sustainability word in front of it. And I'm pretty sure that you know what can be a truly sustainable facade.
Yeah.
So.
For me, it always starts with that discussion we have right now. Right, we have the right people sitting on a project, from the developer to the architect to the engineer. That initial discussion in an early stage. I mean, he's just mentioning it, right? We are in Mazda. They didn't see the lower window to wall ratio as a flaw because they have embedded it in the design. And this is, I think, the early discussion when all of the parties are coming together to find the right strategy for the project, and like all of us together. So it's usually, I mean, we all know it, we would usually get the project when it's already awarded, when it has been going through the competition stage. And then for us, from an engineering point of view, it's usually sometimes too late. All we get is like, oh, we can't change it now because it has been approved. Someone has approved that image already. So there's like no room for us to play around or to optimize it and to rationalize it down. So that's one aspect. And I think Salah said it as well, that designing it for the future to make it future ready, as James had it also on that great example, right? 50 years and you can literally dismantle every single component and give it another 50 years. I think that's the vision we would all have from a developer, to give it an extended lifetime. Architecturally, it wouldn't change as much, and from an engineering point of view, it would still perform as it should.
Thank you. Johan?
Yeah, I mean, great point, by the way, because in Masdar, we actually designed the parking building a bit higher than usual, so it can be turned into office building if needed in the future. And it's an open structure, but it was in that spirit that it could evolve with time. From my point of view, from an architect point of view, the future facade is probably more into, I mean, let's say, short term would be in the materials, and how facade can be, can have that sort of performative aspect where they react and behave in real time with their environment, a bit like your iris in a dark room or in broad daylight. So that's how I see the near future. But the long term is really through future proofing. As it was mentioned at the Tall Building and Urban Council a few months ago, the next crisis our civilization is likely to face is over resources. So if we design a future-proof building, flexible building that can evolve as we also evolve and work on this aspect, we can overcome or sort of prepare for proper potential struggle over resource and have basically a built environment that can evolve with us.
Thank you. Salah, what is your point of view in terms of what are the truly sustainable facades of the future?
In addition to what my colleague said, I can add to them a facade with a lower embodied carbon, and also a facade that is resistant to the climate change.
I think, I'm the moderator, but I would like my opinion, my point of view on this one. I couldn't agree more with what has been said. I think future-proof is crucial. Just to give some numbers, main structure, concrete structure, has a lifespan of 100 years. Facade depends, of course, of the material and the elements. We will be talking about 50 years. And if we talk about the glazing, let's say an average of 25 years. So what happened when after 25 years, then what are we doing? Like, are we just demolishing the building to make sure that we have a building that performs? So if we design properly to be able to dismantle those panels and to upgrade it, because also the glass technology is evolving amazing. Every year in all these conferences, something new comes and that performs better with lower embodied carbon. So I think the best approach to have a sustainable facade, as they all mentioned, is to be able to retrofit our existing buildings to make them perform as per whatever we manage to achieve in 20 years' time, 30 years' time, or longer. Again, we can give 2-3 times of life of building if we are able to design to dismantle everything. So I don't know if you want to add anything else, but it was a really good panel. I mean, I'm happy to share these things with the 3 stakeholders, consultant, architect, and the developer.
I can add, you are most welcome to visit Masdar City at any time. It is open to public, and we are glad to offer you, your colleagues, and your clients a free visit to share with you our knowledge. The goal is inspire you and see you doing the same thing outside and join our race against climate change.
Thank you.
Most welcome. Thank you so much for attending.
Thank you very much.
Thank you.
Thanks.
So I'm jumping back into my other role. Thank you all. Thanking myself. We are going for a break. For all the speakers and the panelists, please stay back for a photo session. We are meeting back in 25 minutes. Please help yourself on refreshments and networking sessions, and we will see you in 25 minutes. Thank you. For the next one, Irina from AGC is going to take us through the journey of glass and selecting the right glass for aesthetics. I hope we all can learn from you. There you go.
Thank you.
Thank you, Irina.
Thank you, Susanna. Wow, so beautiful from here. Good afternoon, ladies and gentlemen. My name is Irina Tadello. I'm the marketing manager at AGC Obeka & Glass, which is a part of a larger AGC group. We are very active in glass. You can see 50% of our sales are into glass, both architectural and also automotive. My colleague Ben, yesterday, he was delivering the speech about the chemical materials, AGC chemicals, and you probably have seen us all around. You have seen us with our oversized glass, and definitely you should know about the project. It's a unique service that AGC is providing called Coating on Demand, that actually you can create your own coating within a matter of a day or two. It's about those flexible and highly durable membranes, about the raw ingredients that are being used in the paints and in the coatings to make sure they are protected by the, protecting the building from the corrosion. It's AGC glass is used, as I mentioned before, by various car makes, and the group is present all around like 30+ countries around the world. But here in this region, we have a facility in Saudi Arabia. We have a fantastic manufacturing production. We have a coater, which produces high-performance coated glass, which is tailored specifically for the region of Middle East. It was built by our colleagues from Germany. Our products are actually cradle-to-cradle certified, and we are basically the only glass manufacturer who has cradle-to-cradle certified products, which are being produced in the region. We also obtained the product conformity certification from Dubai municipality. It's our second year already. And what you see here now on the screen, it's AGC Technovation Center located in Belgium. And this is where our products are being developed. Again, they are specifically tailored for the Middle East region, making sure that we keep in mind very important factors such as the solar protection. When R&D centers across the world, they are working on the new technologies, on the new products. And the trends, you would agree, they are usually coming from the West, from the North America, from Europe, from UK. They develop the products which are designed for their local climatic conditions. And you would agree with me that that's not always suitable for what we have here in the Middle East, right? So before bringing the product which is being developed there, we should really analyze whether it will be suitable, whether it will match the local building code, whether it will address the challenges that we have here in the region, right? So the next slides, I would like that you keep in the context of the Middle East region only. And you will agree with me that the building envelopes, it's like our clothes, right? They protect us from different weather elements, such as sun, wind, extreme cold. They provide us comfort, but they also perform a range of certain social, cultural functions, correct? The buildings, they reflect the certain occupational, social status. They reflect the gender, they reflect the religion. They do create style, if you have any, and definitely they do create the identity. So, talking about the glass, you will all agree that it's a key element and component of the facade. And despite the fact that it is HVAC systems which are mostly accountable for the energy that the building is taking from the sun, there is always a very thin line between the aesthetics and energy efficiency. And I think James was using a very similar slide before, where you have to maintain the balance between these two. So we all know how to make the energy-efficient facade, right? We do, no doubts. In fact, our ancestors, they also knew how to make their homes cool But since the technology was advancing, we were bringing new building materials, we were improving, and we made our buildings to wear a facade with a larger and larger windows. And the trend being today that we have a almost 100% glazed facade from top to bottom. Now, talking about the trends. We see the trends here in the local market. We listen and we keep hearing different opinions from our partners, from our customers, architects, developers. But being a glass manufacturer, we have to be careful and not to bring emotions in. We have to operate with the facts, right? So we wanted to find out what would be the ideal glazing for this region that will have a great aesthetics, that will at least match the building code, that will ensure the comfort for the building occupant, because at the end of the day, we are building for people, for me, you, and our families. And last, but not least, how to choose the glazing that will provide the best energy efficiency to the facade, and therefore will maximize the return on investment. So what we did, we actually ran the study, and the next slides will focus on that. But shortly about the glass, you all know that there are so many different values when we talk about the glass, right? Some of them, such as light reflection, light transmission, are accountable for aesthetics, so let's call it simple beauty. Some of them are for efficiency or energy, and there is a big interlap between many of them that ensures the comfort and well-being to the occupant, to the building occupant. So coming back to our study, I think I have to rush a bit. Yeah. Coming back to our study, what we did, we have designed a building in the center of Dubai. Let's call it Business Bay, 35-story. It's around 150 meters high. We applied 45% window-to-wall ratio, okay? And to make it a very real and to reflect the real-world conditions, we have employed the UAE weather data. What we also have done, we have deliberately omitted any external shading elements to make sure that the building is actually taking the most of the solar energy. I'd like to say here that we are living in a really nice place, and the speed of construction in Dubai is quite remarkable, right? So if you're a developer and you're placing your tower somewhere in the middle of nowhere, most probably in the next 5 years it will not be the case. But in our study, we wanted to show you the worst possible scenario, where actually our tall building is surrounded by the only 5 meters tall houses, buildings, mini towers. So to make this study, we use probably the best software which is available in the industry. It's a virtual environmental software of IES, and we have run around 25 different simulations. My colleagues are here, and you're more than welcome to visit us, approach us. We can show definitely much more than I am able to present you here today. A few words about the simulation setup. So what we have done, we have used the internal heat gain values constant across all our simulations. We also included the factors such as sun path variations. So we were facing our building east, north, west. We were calculating, and we took the weighted average data. And what we did is we took 3 glass products. Here, I would like to make another disclaimer. We are not talking about the glazing. We're not talking about the IGU. We're talking about only one component, which is a soft coating, which is applied on one of the IGU panes. So we have selected 3 products. 2 are produced locally, product A and B, and product C is imported. Product A, B, they are double silver coatings, and the product C, a triple silver coating. The difference is simple. Additional layer of the silver allows you to get more light into your building. Of course, all the 3 products, they match the local building code when the window-to-wall ratio is 40 to 60%. For the base case, we have taken a product which also exists in the market, which is a good enough product that's being used in many developments. It's relatively affordable, $12 per square meter, and please keep in mind this is a price for the coated glass only, not for the IGU pane. For the IGU composition to run our simulations, we have taken 6-16-6 with 100% air, which is approximately 80% of the market requirement. So what we found out, let's talk about the energy. First, about the surface heat gain. We saw that triple silver coated glass didn't perform so well, and we actually found out that glass B, which is available locally, which is a double silver coating, gives us way less heat gain from the sun, and we transformed those numbers into the zone cooling load. When we transformed those numbers into the energy, megawatts hour, you can see on the graph very well that product A, product C, they perform relatively similar to the base case, but the product B, which is double, not triple silver coating, actually helps us to save the energy. So what does it mean to our developer? Please check the price, right? How was it? So we're asking him to pay $22 per square meter, comparing to the $15 for the local product. So we're asking our developer to invest more, but for what? Because at the end, the yearly savings that he will get are so minimal that then the investment is just not justified. While you're using the B product, which is a local product, and the double silver coating, you can get your investment in around a little bit more than 4 years. So the second part of our study was devoted to the daylight analysis and lux. Lux, in other words, is intensity of the daylight. I'd like to show you this graph. Actually, you can see the number of annual sunshine hours, what we have worldwide. Let's draw a line on the north, where you see the Canada, the North America, the UK, and let's compare it to what we have here locally in the Middle East. If you check the numbers here, we will have double of the number of sunshine hours. So back to our analysis, what we have done, we have taken one unit in our tower. It's a corner unit. Usually it's more expensive for the developer. And what you can see here, the software is showing you 4 different zones of 4 different colors, where the red represents the most lux, and the purple represents the less, the lower number. What does it mean? So for your reference, for the human being to feel comfortable, the optimal level would be between 250 and 350. Of course, there would be some people who would say, no, I need 200, I need 400, but on average, it's 250 to 350. Also, the operating theater in the hospital will have 10,000 lux, just to give you an idea. So what we did, let's compare the area which is affected more by the daylight, where you have the abundance of the daylight, which is red and green, right? So if you check for the triple silver coating, the number that we have is 37%, which means it's more than a third of the unit of your, let's say, office or apartment that will not be that comfortable for the building occupant to be there. Whereas the double silver products, definitely the area where you are not comfortable is way less. So in short, or in a simple way, what does it mean? You probably have experienced this, especially here. When you're sitting inside the office, coffee shop, you have a beautiful view, yes, maybe there is some iconic project, but you cannot enjoy it. At some point, you have to protect yourself from that. You have to use the curtains because you have to work, or because you are home and you want to watch a TV. Depends. This is an actual building in London. It was our colleague who took the pictures. He went there in a sunny day, so you can see the close look in a sunny day. And then he went to the same spot, but he went when it was raining, gloomy, and gray weather. So naturally, you would see that in the sunny day, people would use their curtains, correct? They want to protect a little from the sunlight. They want to feel comfortable. But you would also expect that when it's rainy, when it's gray and gloomy, people will open up those curtains, and they will not use the internal lighting as much. They will still try for the sunlight to come in. But it's not happening. So our idea was actually to check the behavior of people, the behavior of the occupants of this particular building. And the pattern is that it's pretty much the same. So the question is, the idea is nice. We want to bring a lot of light and to create a beautiful space. But the question is it beneficial? Because on top of that, building occupants won't be comfortable. You will have to protect from that. You will have to use the curtains. Yes, I'm finishing. Thank you. So conclusion is very short and straightforward. First, let's not copy-paste the solutions from the West, and let's build for the local market. And second, let us please respect the developer, and let's not make him invest into something that doesn't really bring the value. Yep. Thank you.
Thank you very much, Irina. AGC is around in the exhibition hall if someone is interested in taking any discussion further. For the next speaker, I would like to invite Eddy Abou Khalil on stage. He's going to give us an insight of Cosentino's current services and profile in the Middle East. Please.
Good afternoon, everyone. In this year's edition of Zak, we decided to talk about us, about our company, our products, and about services. So we will walk you through a little bit about who is Cosentino, why to choose our surface Decton, which is the surface suitable for facade, and how we are your partner when it comes to facade projects. Cosentino is a global manufacturer and distributor of engineered surfaces. One of our surfaces is Decton, that we will discuss today about it in our presentation. And we are based in Almeria in Spain. All our production facility is based in Spain. However, from Spain, we ship all across the globe. And I would say our business model is quite unique in our industry. We're either the only one or one of the very few that have a representation, an office in every single major city around the globe. So unlike many other players, you don't find 1 or 2 employees in some cities. You will find a full-fledged operation, like the one we have in Dubai for the UAE. We have a general manager with his team of professionals in sales, marketing, logistics, administration. We have an amazing showroom. Currently, the showroom in Dubai is in Dubai Design District with a showroom team, and we have a warehouse in every city that warehouses slabs. For instance, in Dubai, we have around 3,500 to 4,000 slabs to serve your project mockups and some projects deliveries when the quantity is controllable from our stock. Otherwise, we ship from Spain. So you have us next to your door. You have another office of us in Saudi Arabia. Talk about our region, and then so on and so forth, as you can see on this chart. Decton is not a porcelainic surface, and we struggle with this every time we go to meetings. Decton is not like any other sintered stone, and there's a reason for that. Decton is an ultra-compact surface because it's the only surface on the market that is compressed with 25,000 tons. What is 25,000 tons? If you want to imagine it, is 2.5 Eiffel Tower. So 25,000 tons, which is a minimum of 20% more than any other sintered stone or porcelainic surface on the market in terms of pressure. What does this give us? It gives us high technical characteristics. It gives us an amazing flexural strength, the highest in the market, and which makes Decton a technical product. Decton can be used anywhere, right? Because this surface, we can see the characteristics now. It is not affected by UV, UV resistant, is abrasion resistant. You cannot basically stain Decton. Any paint, any graffiti, anything on the surface, you can clean it with any type of chemical, no problem at all. It has an amazing dimensional stability, so no issues of contraction and changing of the size of the material when installed outside. It's super flat, so you can install large size panels on your facade without worrying about the alignment of the facade, bearing in mind that the surface comes in 3.3 by 1.6, and then we can reduce the size as however we want. It can help you with the weight on your project structure. We can discuss it in a bit. So it has amazing characteristics. It's definitely non-flammable material. So you can use it from a very simple application like a kitchen countertop on a vanity top or flooring inside the house, wall cladding, furniture tops, or it can go outside the house or the building to the landscaping, to the garage where you park the cars, to the fence wall, perimeter wall, or even to the villa walls, exterior walls, or the high-rise towers walls. I give you an example about weight. There was a project specified 8-centimeter granite. Because of the pressure and how much Decton has in flexural strength was reduced or replaced by 2-centimeter Decton. So this shows you how much we can help the building structure when we use such a surface. We can use 4 millimeter for your facade glued on a honeycomb, or 8 millimeter directly adhered on the wall, or semi-mechanical fixing if you want to call it, or 12 millimeter with mechanical fixing if we're going to use undercut anchor or any type of application, of systems. Freeze-resistant, of course, some examples to show it. Fire-resistant material, it doesn't burn. Basically, the material doesn't burn. We have all the certification to prove it, local and international. We have a system test, NFPA 285. And obviously, the material, we can see it's rated A2. It's because of the back mesh that we apply on the back of the surface for additional safety. However, without the mesh, the material is A1, is non-combustible. Earthquake test. Sorry, so this material, I would like you to focus on this side of the panel, because you can see clearly what's going to happen later. That's an earthquake test we have done in Taiwan for a project in Paris. And look at the surface at the end. See now. So the high pressure that I just spoke about earlier, this is where it comes into play, that turns Decton into a technical product in such kind of conditions. The material is super flat, as I said, so we can go as big as we want. We can even put the full size of the panel on the facade. We have done a massive, more than 65,000 square meter project in Abu Dhabi using large size panels around 2.5 or 2.8 meter in length, 1.2 meter in high. And the project is there on Saadiyat. We can see pictures in a bit. It looking amazing. UV resistant, as we said. You cannot stain the material. There's a short video here which I will try to fast forward if possible. So graffiti is being applied on the material. I'm sorry. Maybe there's no way. There's no way. So graffiti is being applied on the material. As you can see, this is in our showroom or in our center in Miami. And then later on, we can clean this graffiti with any type of chemical. We used acetone here to just remove the graffiti, because the material is non-porous. So now the cleaning start. I'm not gonna let the whole video run, otherwise they're gonna start ringing the bell for me at the end of the presentation. So as we can see, after the video is done, the surface is back to normal. Amazing mechanical resistance of the material, which makes it a fantastic product for a facade installation, and the mechanical fixing for a facade installation for high-rise towers or any type of facade. Dimension stability, as I said, so we don't have to worry about expansion and contraction of the material. It's an abrasion-resistant material, so we can have it in the desert with sand erosion, resistant sand erosion, or any salty area in front of the sea is no problem at all. Talking about sustainability, sustainability is a very dear topic to Cosentino because it runs in the company's DNA, in its every single process that we have at the company is not only in our surface Decton. Bearing in mind that Decton is the only cradle-to-grave surface on the market, as we offset the total CO2 emissions during the whole life cycle of the product. So we reuse and recycle all the water that is used in our production process. We have recyclable material inside the surface. So we have all the certification, again, that you need for any project to prove our sustainability. This is something very interesting, Decton ID. True, we have our palette of colors that, like any other suppliers, we have our standard palette of colors. However, our fantastic state-of-the-art facility in Spain, given all the volume that we can produce and all the machinery that we have, we can customize for your project a color that you need. We have done it for Burj Al Arab in the past, for the flooring of the project, the hotel, inside the hotel, obviously. We have done it for a developer in Dubai without naming names. So we have a surface now called in the company name, and they chose the gray that they want, and they chose the vein that they want. It's not an imitation of a natural stone. Their design team designed the surface, and Cosentino did it for them. We have done the same for Amala in Saudi Arabia. We have a stone now called Amala, which is only done for their project. And as you can see, you don't get this copy-paste effect on the surface because we don't print and print and print and print the same print everywhere. The last thing that any designer or architect wants is a copy-paste effect and lose the amazing feel of a natural stone, right? So we don't have it with our surface because we move our print 10 centimeter on the length, which is 3.3 meters. So we have 33 versions of the stone. Talking about certifications, we have them all. The Dubai and Abu Dhabi Civil Defense, the logo is there, and all the other certificates are there. So how we can help you and how we can be your partner on the project, we can support you in all this journey of the product. So we are not only a manufacturer and a distributor, because then we become a supplier of material, and this is not the aim. We have a team that escorts you along all the life of the project. So from initial counseling, you come to our centers, you come to our showrooms, and we choose the colors together, we choose what is suitable for your project. Together, you tell us what you want, and we advise you. Obviously, we can do the budgeting for your project. Needless to say, we have a team in the company, R&D team, that can support in case we need to develop a special texture for you. And what is very important, that we can help you with the facade design. I'm not saying that we are smarter than the architects, but sometimes the material has specific dimensions, and to be more efficient when it goes into bidding and to the hand of the contractors, we need to look at the dimension of the material and how it fits on your facade. And not only looking at the material price, for one of the projects, before it was even built, because we were involved at the very early stage, they had columns every 2 meters on the facade. And these columns were built with concrete. So we advised the owner, we said, why you want to build concrete, pay for the concrete, and build these columns that are only for decoration. They are not supportive columns, just for him to have the columns. So we built these columns, obviously using, because he has Decton on the facade, doing the shape of the column with Decton without having the concrete behind it, only using the metal structure. They saved on the concrete, saved on the cost of the project, and the owner was very happy. In other projects, we shifted a bit the windows just to fit the material and reduce the wastage. So we are there to support you also on the technical side. Mock-ups, obviously, we can do your mock-up, we can do renders, we can do, if it's a new surface for you, we can give you digital render first, or digital color, or sample of the color, and then we can do the facade for you, do the full-scale sample for you. What is also additional to our production facility of slab, we have a state-of-the-art fabrication facility at our factory in Spain. Amazing, all robotic, it has everything. So we don't only send you the slabs to your site, we can even cut them at our factory. We use this facility to service our client, not to compete with any other fabricator. So we can cut them for you at the factory if you need. We can even mechanize them, so we can drill them if you are using an undercut anchor from Kyle or Fisher or any other supplier. We can assemble it for you. We can put the anchor, we can put the clamp at the back if you also need that. So we can do endless things for you at our factory. It will come to your site like a plug and play, it's like a puzzle. You just assemble it on the building. And we work with any system. So undercut anchor, as we saw in this video, we're gonna see also the continuous groove. I don't know, not sure if you saw already the slotting. We can do the slotting for the side. So any system we can adapt, we have the machinery for it. This is the slotting, for instance. Still talking about our fabrication facility in Spain, we have a huge capacity, 100,000 square meters a month, plus other factors. Logistics, obviously, we ship all over the world, and we will definitely market in the boxes and in the packages the way you want. We don't have a rigid way to let's say, number it. You say, I want to number my pieces, floor number 1, piece number 2, east facade, blah, blah, blah. We can follow the logic that you want. Support during installation, we can bring our engineer And by the way, again, this is very rare for stone companies. We have our own full-time engineer based in our office for the region that can give you support. At the moment, we are seeking the support from our neighboring offices from South Africa or from Turkey. However, Cosentino Middle East will have the first headcount in Q3 based in Dubai for the region to support you in installations. Warranty, our amazing 25 years warranty is always there to support you. I'll give you an example. I think we discussed that, sorry. This example is gone. So to wrap it up, I still have 1 minute. These are some of our projects. This is the one in Abu Dhabi, Qaryat Al Hid, in Saadiyat Island. More than 65,000 square meters of material has been used over 12 buildings of 5 floors each with, large size panel. We can see them. We can see the panels. That's one panel on the facade, and you can see the rest of the panels. DoubleTree Hotel by Hilton. We have so many. This is a villa here on Al-Wasl, right? Where we have 2 cores of Decton on the flooring facade. We can do also your swimming pools. We can do jacuzzi, sauna, anything for the surface. And I said the perimeter wall of the villa and more projects on this presentation across the globe. And that's a wrap. Thank you.
Thank you very much, Eddy. Eddy is also around if you have any further questions. We will go for a short break. We are pretty much on schedule if you all want to be back here at 3:30 to listen to our design director, Valeria, and enjoy your break, 15 minutes. It's a short one, but we are back on schedule with that. At 3:30, we will resume. Thank you. Hello, so we are back. I'm glad that you all made it. It's really nice to see how well visited we still are by the end of this afternoon. We do have 4 more speakers for today. We will start with the design director, Alina Valcarce. She will get us into the journey of architecture and facades. So enjoy her talk. Alina, the stage is yours.
Thank you. Can you hear me? Yeah.
Yeah, you're on. There you go.
Thank you, everyone. It's a pleasure to be here. Firstly, we have here amazing speech today about technical details and suppliers and how we can really get built our facade. I wanted to bring a little bit of this different approach of technicality and trying to bring a little bit more of imagination and how actually that initial stage come in. So that's why I bring it today, the topic of imagination to inspiration and what is actually happening behind those stories on the building that later on engineers, facade engineers and suppliers really need to work on details to make it happen. Just for the people that doesn't know me, I am Alina Valcarce. I'm the founder and design director of Valcarce Architects. We have an office in Spain. I am Spanish myself. We have Ho Chi Minh City. I have spent about 16 years in Asia. The company is now here in the UAE as well and in Saudi Arabia. So we are having very beautiful projects in the region at the moment. Some of them we cannot really show. Many of you know that everything is under NDA, but we are trying to show a little bit more on the projects that we actually worked in Asia before. So a little bit more about storytelling, about the genesis of design. For us, storytelling is one of the best way to explain our architecture. Also, as a designer, we really wanted to make sure that behind every project we have a narrative that connects with people, that connects with feelings. We wanted to make sure that every project that we work on, it really has a story behind. It has something to tell. And yeah, we will have beautiful structures coming up. There is a really beautiful building, but it's to really making sure that architecture connects with people is creating a narrative and a project that really try to connect those emotions in people's life. So I'm going to bring a few examples. These are just sketches of projects that we have been working on. The first stage in our project is actually trying to tell the story to the client itself, to the developers, to the investors, and trying to make sure that they already connect the project and they have their relationship of their design with architecture, and then they can actually tell and go and sell to the end user or invest. But the first step is to tell the story to the client itself. So this one are just, I wanted to bring a few examples of how actually we start completely, like before even trying to analyze, go to numbers, even GFA, even going to more technical details or of the land itself, we try like, what is the sense of the project, why we are doing this project, how we can connect the client itself, the investor, or the end user with the project. This is an example of how we started just one. It was actually that image at the left. The client here, the investor, it is for a car seller. And it's for a sport car. So it's like how actually we can connect the story of the client with the architecture itself. And we kind of have always a brainstorming, but we always try to create one image that is going to represent the concept, and it's going to create that connection between the client, the architecture, and the end user. This is this tower itself was for the headquarters of this company. And if you see the sketch itself, it's kind of trying to bring that movement, that fast connection, that kind of shape of sport cars into the architecture itself. And of course, there will be developments. We need to follow regulations, technical details, but all of that can really come. And we all know the regulation, but that first initial stage of connection and stories and narrative of the architecture with the building is really important for us. This is another example, and this is it's a quite cute project, actually. It's very small. It's in the top of the mountain. It's in China. It was initially was for the Winter Olympic 2022 that it then got postponed. But the project is in the top of the mountain, and it wanted to connect with the skiers. It was supposedly to connect the snow with the architecture itself. So we wanted to show that movement into the architecture. It was just a small clubhouse, mountain top restaurant, but how we are going to actually, how we try to manipulate the very initial massing with the skiers itself, with the connection with the surrounding mountains. We wanted to bring a little bit of, that's why we have two different layers of the project, one that is representing that snow, one that is representing that movement, and how we wanted to, if you see the shape of the building itself, it's kind of a flower. So the mountain, if you look at the location of the site, you have a mountain, and in the top of the mountain, you have this kind of flower or a snowflake. And the mountain is not always on snow. You have the summer and you have the winter. So during the winter, we represent that snowflake just getting in the top of the mountain. But in summer, it represents that flower, that spring flower that come at the top. But at the same time, if you see that movement, the building kind of rotates, so it shows kind of the movement of the skiers actually playing on the side. This is just a diagram. I didn't want to bring technical details, technical drawings, because we have seen a lot of that today. That they are amazing, and one of the presenters I really like, it was Osama. I absolutely love facade designer because we cannot create this. This is just the initial stage of the project. Like we start with very conceptual idea diagram, and to see how each stage of the project and actually how we move from this kind of representative narrative of the project to finalize, getting into detail. And I suffer some time, and I see the faces of the engineers trying to solve our initial sketches, but it's so beautiful to see how kind of each stage from this initial sketch come to reality. This is another project. I will show you the build picture later. Again, it was in the same location, same client at the top of the mountain. He liked it a lot, the concept of having a winter phase of the project and a summer phase of the project, because the mountain is not always in winter, but the main activity of the mountain itself is for a skier. So in this project itself, it's like, okay, looking at the different point of view, we have the snow, and we have that kind of come down in small snowflakes, and we have the fire that can represent a little bit when the snow starts to melt itself. So we try to bring those patterns into the facade, and that's how, just kind of by small dots into the aluminum itself of the facade, one massing will represent the winter, while the other massing will represent the summer. This is the render itself. The project is still not completed at the moment, but almost finished. There is a lot of interior to work on that yet, but it is quite a cute project. The client really has what they wanted. It really represents a lot for their brand as well. So if we start to connect those the people that are residents that live around surrounding this area itself, really like the project. That for us is really important as well. The mountain has a lot of curves, so the project is kind of actually following the shape that is already there. It's not like we are just bringing curve to a side that doesn't need curves. This is a project under construction. There's still a lot to happen and a lot to going on, but we are getting a little bit slowly there. The patterns that the client wanted are there, and just another example of how initial sketch really come to reality. This is another project. Again, we are talking here about imagination and about storytelling, and I think it's really, really important. In the region, and sometimes actually I have found that many of the buildings, even some of our clients right now, are coming to us to kind of fix an initial architecture. And for us, the first step to start any project, we are working a lot of high-end residential, high-rise building at the moment here in the UAE. And the first stage is like, what we wanted to achieve here? Need to have a story, need to have a narrative. What kind of people are going to be living here? What kind of people you want to buy these apartments? And that all comes from the concept initial stage. And if there is no concept, just having a massing and a structured building built, it will not have that connection with the people. It will not have that connection with the city. This is another example. This one was the client itself is a big headquarters for a researcher of DNA. So they wanted to build their headquarters. This is in Shenzhen, China. And the base of the company is to study DNA of the people and how how they can improve health of people through studying their DNA. The first thing that comes to our mind is like, okay, if this is the sense of that we are building their headquarters, the building itself needs to have that connection with the company. And we thought about DNA. It's like how we can bring that structure into an architecture design. This is a little bit of the building, and we will see more later, but actually the building will kind of replicate that kind of circulation that the DNA itself, the atoms itself produce, and kind of bringing and representing itself into architecture. So that's why we call it inspired of a helix design. It's actually replicating that DNA structure itself. And that's how we have those bridges connecting. We're having two towers. One will be the headquarters of this company, and another one is a service apartment that it will be really for the people and residents of people working on this tower. So we really wanted to make sure that people have that connection. We were not two separate buildings by itself, but they actually could connect in different levels. So that initial concept of double helix actually helped to create that connectivity between both towers and not be two completely independent towers. Also allow to connect in different levels, so you don't need to come down and come back up. You can actually connect in a few different levels on the side. The facade itself, we wanted to replicate that atom. So you will see that mesh facade replicated that hexagon change that come there. Again, this is just, these diagrams never need to be there. We don't really need to put the conceptual diagrams on it on the report, but for us it's such important graphic to represent what we are trying to do. And we really, sometimes they are very graphical, they are very conceptual, but the clients, the developers, they really understand our idea behind the design through those diagrams. So for us, it's really important to show them in any of our presentations. This is the project itself, and you can see actually how that relationship is coming and representing into the initial sketch is coming and representing to the architecture. This is another view. I kind of like this top view because you will see that double helix moving around those towers and really connecting them. And you really, those spaces initially, we were discussing what they are going to be, what is going to be the connection, but at the end, we found so much use for the client on those bridges that connect both towers, because they really wanted to have amenities areas, entertainment area, that actually those bridges kind of acted as a gap and creating the relationship between the two volumes. This is another example. Just different ones, very different. This is not a high-rise. This is a resort. Our company itself, we develop a lot of hotels and resorts. Right now, we are working in quite a few resorts in Saudi Arabia, but we cannot show it yet. So I bring another example of another project that we worked in the past. This one, the beauty of it is like we really like to connect with nature. We really like to connect with the surrounding. When they give us a canvas to play inside with the nature itself, it really inspires us. This site is in the outside neighbors of Shanghai, so it's much more rural. But they have so much local touch and local culture on the side that we wanted to bring back to our project. It's in the mountains again. So this just conceptual image is just to the first stage to start to explain what we are trying to do on the side. This is the project. It's a very different scale, and sometimes I really enjoy to be working on a low side as well, to working in that nature, because it really we can really create that connection with the surrounding, and more when we are not working on cities. In this case, they have a lot of factory in this location. They have a lot of factory about ceramics, so we wanted to bring that ceramic, one of the main materials to be used in our project, so we can actually support the local factories to the new developments on the site. So if you see, the ceramic have been implemented in practically, well, in all the roofs of the development. We have this beautiful soft canopy or roof that is the main element of our design. You will connect in this resort itself in many different levels with that canopy and really stand out in the whole development. It really connects very softly and gently with the mountains behind, so you don't see that you are just implementing an architecture into the side. It's less the architecture, the landscape are talking to each other. That's something that we really try. Another element from the concept initial stage, we really try to make sure that landscape is part of our architecture. I cannot understand, even myself, I sketch, I am the founder of the company, but I sketch myself. I love architecture, and for me, that initial stage, that conceptual idea is the one that really needs to be right. If that concept initial stage is right, the project will move smoothly. If that concept stage, that initial design is going on the wrong direction, there will be so many problems. The project will get delayed, and everything after will go more difficult. While if that initial stage, everyone is happy with that vision of the project, everyone is happy with that initial imagination that we are bringing to the site, then you have the right path to keep moving into every detail of the project. But we really need to make sure that that initial conceptual imagination is really in everyone's vision, all stakeholders of the project vision. This is another image of the same project. This is another example. I am getting out of time, but this one was we wanted to connect with Chinese calligraphy. The project itself was in a lake, and we wanted to make sure that it's a resort, one of the biggest developers in China, and the project was surrounded by water. So it's like how we can bring the culture of that Chinese calligraphy into our design and feel like you are kind of painting on the side. So that's how, again, this is just a diagram. It's just an initial concept idea, but I think it shows quite clear that imagination and that narrative that will come with the project later. So we really wanted to kind of brush and paint the building into the side. This is another image. This is one project here in the UAE. We'll start construction in Q3. The launch was last month, so I'm able to speak a little bit more about it. It's a luxury residential development in Dubai land. And again, the client has another consultant and come to us like, we really need to relook at the entire project. And for us, the most important is like what kind of concept we can bring to this side. And the first vision from the client is like, I want a lot of water on the project. I wanted to make sure that even we are in land, we want to have water on it. So one of the first elements studying the facade that it will come with a lot of talking and discussion with the client was kind of bring that wave, that kind of track that the water leaves when it arrives to the shore into the project. This is how the facade final look. We have a lot of water as he wanted on the podium level. We have water levels in the and an elevated amenities level, and we have a lot of water in the roof. But the facade itself is connected with the water that he wanted. We bring that kind of silver elements to the facade itself, and that kind of silver elements come as well from that sunset look of the sea and kind of track that the boats live on the water. So those kind of delicate elements is what really make the client and connect the client with their projects, and I will connect the users and the buyers to the project itself, because there is a sense of narrative, there is a sense of connection of a story behind a design that they are going to live in. So I think that's quite important. This is the project itself. You can see the detail of the balcony and how in a very delicate, we don't have entire project as silver, but we try to integrate that silver touch into the facade and into every element of the design. We have all the water that he wanted. He really, something I am finding a lot in the UAE is like a resort-style residential development is coming more and more often. The good thing about us, because we have that knowledge of hospitality and resorts, we have been developing hotels and resorts for the last 10 years, kind of bring us that opportunity to bring that knowledge into the residential playground nowadays. And I think that's good because the point about hotel and resort is like we are really trying to when we go to a resort is to enjoy life and to have a healthy quality lifestyle. What we are trying to do that now is to bring that healthy quality lifestyle into your residential space. We are kind of blurring what is residential to what is hospitality. This is just another project that we are working at the moment, but in this one, what I really wanted to show is like we are really trying, many of our projects, we are trying to reconnect with nature and trying to bring that green space and that landscape and create that microclimates and mix it with architecture. Architecture and structure, they should not be independent. They really should be connected. And when we are developing cities, it's not just to start massing and build from the ground. We really need to see and reconnect what is with either the surrounding, or if the surrounding is not there, how we can restore the surrounding. So this is just another example of one of our projects that we have at the moment. And just to finish, I just wanted to finalize and to reiterate the importance of storytelling in architecture, how narrative, when we have a story, when there is a narrative behind the building, we will create more memorable buildings. We will create those designs that will connect with people, that will have a better experience and they will appreciate it differently. So if an end user sometimes even doesn't know, even knowing the story, you can see that there is a narrative behind the architecture and the design itself. And also an architect and a storyteller, we are always storytellers. And we need to make sure that our cities are more, we are creating the narrative for people and for for all of us to live on it. So this is just a little bit of a break from that technicality point of view that we have in the other speech. And I love technical details. I completely enjoy to develop a very initial sketch that doesn't represent anything more than an image, and to details to making sure that it comes to reality. Thank you so much for your time, and I'll let you.
Coming for you. Thank you so much, Alina. I absolutely love how you find your inspiration in nature and things we are surrounded by every day. Very great presentation. Thank you so much. Next, I would like to invite Mercedes and Rosario on stage. Our colleagues from Arup are taking us through some facade engineering challenges on different projects in the region. Mercedes and Rosario, the stage is yours.
Yes.
Very good.
Thank you,
Can
Susanna.
you hear me?
Thank you all. Thank you, Susanna. My name is Mercedes. I work for Arup. I've been 20 years in the facade industry. The last 15, and Arup, for all of you who know, it's a global multidisciplinary consultancy. Along with me is Rosario, who is going to be also presenting some of the projects that we're going to show you today. Our talk today is going to be about innovations. And we question this a lot in ourselves. Our mission in Arup is to shape a better world. And that's required us to be always forward-thinking and always trying to push boundaries and create something different. But we question many times ourselves, what do we need? What do we need to really innovate on projects? And normally, it all starts with a dream. It all starts with an idea. That idea needs to be materialized, and needs to be materialized on a design that is feasible. But then that design in our construction industry needs to be real, needs to be happened and be built. This workflow, where it looks very simple, is embedded in any innovation projects we have in our fields. And then it also gives us a glimpse of the parties that need to be involved to achieve it. We at Arup sit on that designer's engineer corner. We are those that has the experience, the skills, and the creativity. But we cannot innovate alone. We need to partner with others. At the heart of all we do are our clients. And our clients will always look for those who are visionary, are aiming to bring forward and to break the status quo. But also we recognize we need those builders and we need the contractors, which are the ones that have the procurements, they have the supply chains, and also the facilities to make it real. And the most important, and that we all need to be joined by trust. That trust is what it joins all the parties to be able to make it happen. When those parties get together, we're able to create a comfort zone, and we're able to create synergies and a platform for all of us to create and share the same aims. And when that happens, when the parties work together, is when we get that breakthrough moment. It's really important, and that's the moment we're able to, all of us together, working in the same, we're able to have a greater results that each of us will achieve individually. Today, Rosario and I are going to be talking three projects in that we believe we have been pushing boundaries. These three projects are in the UAE. One of them, we're going to be talking about the water future of the Atlantic Zero Royal. Second, we're going to be talking about Lamar, a residential development that is coming up in Dubai. And lastly, about the airshed idea and the prototype that we're testing at Masdar City. With Atlantis, we need to start with that vision, that dream that our client, ICD and Atlantis Development had for that resort. This extract this image is taken from the brochure when the project was launched a few years ago, where the impossible becomes possible. That really reflects the work we have to perform there. Atlantis was very clear. That resort needs to have water. We want the guests to be connected with the water all the time. And to do that, they engage with WET. For all of you who don't know, it's an LA-based company who is behind many of the water futures, the most prominent here in Dubai, like the Burj Khalifa fountains, the Burj Al Arab, and more recently the Expo Water. WET came with 7 designs for the hotel, which are now spread all across the resort. 2 of them, the first one, Alight, it was combining water and fire. The idea it was to welcome the guests as they come into the hotel with that show. The second ones were the Luge, which are a pair of glass lifts that as you come from the lobby to the mezzanine, also you have cascading water at the side. With the excitement you can see of ICD with these 2, also there rise a lot of challenges and questions, as the glass was playing a very pivotal role in these features. Will this explode? We're putting fire in a hotel lobby. Will there be a smoke for the guests? And what about the glass? Will they be able to sustain the lift and also to cascade the water? So with that, it came the conclusion that they needed to have a glass specialist in the room. And that's when we got involved. We had been, with previous experience, designing many glass engineering structures and also building the future water. We get to know this project. And we were given a design for a light. It's just a pair of twin glass, which are then encapsulating water coming from the top and fire coming from the bottom. What was given to us was a rectangular grid with the standard sizes. But our first thought was like, we cannot have horizontal joints, otherwise we will prevent the water to cascade. So we eliminated those joints. And then we start, as traditional, we're trying to remove and get a flush facade and move it all the frame into the inside of the cavity. But then we were talking to WED, and they were very clear. We cannot have anything in between the glass walls, because that's where the fire needs to dance. You need to eliminate all the components. So then we're trying to then look and do, can we do just an all-glass facade? But then again, we found that the industry, it has always a limitation of the width of the amount of the width of the glass. So it required to have vertical joints. And that's where we met the joints, which is our weaker point. And it was the point that maybe we have a smoke going through that wall. And then we performed different ideas on the framing, so trying to create a pressurized joint on it. As you can imagine, several studies were undertaken. There's a lot of structural studies to separate the wall completely from the typical and traditional movement on the primary structure, which is making just a freestanding walls. The materials themselves have to go into a very deep research, because material that we normally use for a typical facade will not work here, as they are going to be in constant exposed to water and fire. We end up with a design with 4 layers. We have our laminated glass, which is allowing the water to cascade, but also protecting the user to be in contact with the fire. This laminated glass was really important to be able to assess the temperature. So at the moment, we have infrared cameras always monitoring the glass. So if the fire goes to a higher temperature, the system is able to switch off until the glass cool down. We also have a set of structural silicones who were bonding the glass to the carrier frame, and that carrier frame, that's the important one, to pressurize the cavity to enable the smoke to go up instead of inside the building. And then finally, we have our supporting structure, that to be able to match with the entire design, we have to do it in mirror stainless steel. When we were looking to the cross sections, and that's where the important things start happening, we had big chambers, and we needed big chambers at the base. At the base is about 2 by 2 meter chambers where we have 21 gas burners putting the fire inside. And at the top, in addition, all the water mechanisms to allow the water to flow down, we also needed to create a ventilation and fans to allow the cavity to work as a chimney and extract the air and the smoke. For the lift, we're also very similar. We have to detach it from the main structure. And again, we have to remove all the horizontal joints to allow the glass to. So basically, the structural concept that we came to was very simple. We have a rim at the base and a rim at the top, and our glass span from one to another, and they're separating 11.2 meters apart. But also, we have a lift inside. I don't know how many of the rooms are used to lift designs, but lift needs guide rails. The guide rails help us, the cars, to go up and down. And those guide rails were required to be supporting from our glass shaft. But normally, you're penetrating with fixings and with bolts, but we didn't want to have nothing of that because we needed to separate the water from the lift. So our team came with the idea of using a transparent silicone, sometimes known as TSSA. But once again, it was quite novel. It had never used before in this side of application, so we needed to actually test it. And that's when the question comes when the design was completed. Who can then test and build this design? On that, after many people were interviewed, I believe Cele is in the room. Cele was selected to undertake this work, who has been behind many of the construction, the glass construction around the world. We're starting, once the design was validated, we started with all the testing to verify that structural silicone, that it was able to sustain and transfer the load. And similarly, we have to bespoke a chamber and a test procedure to be able to test joints to be able to keep the smoke inside the chamber. As you can imagine, the performance was one thing, but this is a 5-star hotel lobby, so all the materials need to look pristine. So it was really difficult to select the materials that will perform to the durability, the requirements required, but also to maintain the aesthetics. We have a few pictures of the construction where we can see the dilute, those rings that I was talking top and bottom, and how the span just simply spanned the 11.2 meters from one to the other ones. When we came to a light, I know they silly have to do magic to be able to put the glass, 10.2 meters glass on that we have in our lights through the small holes and then be able to rotate it to install it. And then parallel to the glass, we have all those chambers at the base. Let me see if I can. That was going to host all the gas burners. All of this one to have that show of the water and the fire, and there's glass protecting the user for it. Those two pictures are in the hotel lobby on the Atlantis, and I invite all of you to visit and enjoy it, now that you know the secrets behind it. All of this, to be able to design all of this one, we have to go back to principles. It was not a system in the industry available to do, so our engineers have to go back and think rightly what it was they actually needed. All this research was undertaken to be able to carry it out is now available, and it can be used for further improvement and other applications.
I'm going to talk about Lamar project. This is a Lamar developer and DCA architects. It's a multidisciplinary Arrow project, and at the moment it's in schematic design. For this, the vision of the client was to do a low carbon global exemplar, and we're doing this with a LEED certification scheme, core and shell, and net zero carbon. Sustainability has a lot of aspects in it, and what I want to focus on is an operational carbon and embodied carbon. For operational carbon, we assess different shading configurations, depths, and heights, and amount of shading devices. We assessed over 900 options, and we sat down with the designer in order to choose the better methodology. We set up the client ambitions, key parameters, and put it in a nice visual way. We used our unique script in Grasshopper, and we chose different parameters, daylight, views, solar radiation, sun hours, and the volume. Different shading fins would provide different volume. Views was an interesting aspect because it doesn't have a numeric value. So we had to set up a numeric value depending on the peripheral views vertically and horizontally. We put all of these options, all of this assessment into one platform, our in-house platform, parameter space. And so we had different inputs and outputs, and all of these options, 900 options, we chose 4 options, one at each end of the scale, and 2 middle options. Depending on more solar radiation, we would have less volume, and the less solar radiation, we would have more volume. So this would impact in the embodied carbon of the shading fins. And so we assess different materials in order to reduce the embodied carbon of the shading fins, which assess UHPC, stone, terracotta, aluminum, GRC. Each of these materials have less or more embodied carbon. So depending on the material, you will have different substructure. So we assess different strategies for the substructure. We also thought about different perforations in order to reduce the volume. And all of these options would have a different impact on the embodied carbon. So we did a preliminary assessment, and as you can see in the dark blue, would be a different substructure, and the light blue would have less embodied carbon or more. The light blue represents the material itself. So for instance, a stone panel would have less substructure. We chose a pre-stressed stone, but it would have more material. And then at terracotta, for instance, we have less embodied carbon, but more substructure. But it would be a lighter system. So we also thought about the impact of the system into the main structure. So we assessed the weight, and terracotta would have a less weight compared to a stone or a precast panel. So we combine all these graphs in order to understand the less impact of embodied carbon. So what we ended up choosing was a stone panel with a UHPC substructure in order to reduce the embodied carbon of the shading fin. At the beginning, we tried to assess an active system, but the active system would provide a less natural feel. So the aim of the client and the designer was to have a more natural feel, and the UHPC with a stone veneer was the better approach. My colleague is going to talk about an active system now.
Mm-hmm. Thank you, Rosario. So the last project I want to show you is about the airshade and the prototype we're currently working. So airshade is an idea that it was developed, and it was by the founder, Nicholas Saunders, where he wanted to, despite the traditional movable components and movable shading that you need electricity to move, he was already at if we get air and we're able to move to increase and decrease the volume of air, that will give us power, which then we can activate. Nicola, after many years of working on that idea, presented that to Master City, which you all know, and they're always at the front of looking for innovative ideas and solutions who helps to reduce energy and carbon. Master City really liked the idea and they wanted to explore it, if that would work, but they weren't sure if that would be possible. So again, we were contacted. We had been designing many movable components in the regions. One's the Albahar Towers in collaboration with ADAS, and the other one's the movable panels on the Apple Store in Dubai Mall. So Master came to us and asked us, is that really feasible? Can we make it work? So as a starting point, we look at what was the concept. So we have an air tank. Let me see if I can point it correctly. No, doesn't work for me. One air tank, the red cylinder, which contains all the air. When they get hit and expands, it hits an actuator. We then push a damper and is able to move the panel. We were looking at it and then and assessing all the loads that you need to move the powers. And there is a combination of loads. You will have some wind loads that oppose, you have some frictions, but also you have the gravity of the load of the panel. So we were assessing how we can overcome those loads. And one of the questions we raised is like, can we remove the gravity loads? Because it was the one that was creating most problem to move it. And the answer was yes. We could find the solutions in wind turbines and we're also in the airplane helix. We have to create a counterbalance panel, which basically means you have to create the gravity of the panel, the gravity center of the panel needs to be on the center place as the axis of the rotation. So we added a counterbalance, and we added that extra weight that held the panels to move. When we were studying and we were assessing with engineering and our numerical assessment how much that will affect, a normal panels with being counterweighted, we needed about 70 degrees jump to be able to move it. But by counterbalance, we only needed 15 degrees jump to be able to open and close the panel. So with that, and along with the Master City and Airshade, we developed a reference design and a prototype that we were able to test it. And as similar as the previous ones, we needed someone who was able to build it and believe in that idea. At that time, we interviewed many companies, and at the end, Meta Decor was selected to take and upgrade that prototype. That prototype was created last year in the Netherlands, who then was tested using very similar air pressure, solar radiation, and temperature that we will have here in the UAE. And then the real time came last summer when we were able to ship the panels to Master City. This is on the solar hub of the Master City, where the panel is there since August last year, and it's going to be through a year. We're collecting the data to see how the sun is affecting that air pressure and how it's open. The video is a feature from a one day, so you can see it starting from the morning, and you can see on the panel as well, on the solar panel at the base, how the shade is casting, and you can see how our panel close and open only using air. Just to summarize, I think we have 1 minute left. I want to bring an emphasis on that circle of trust that I was putting at the beginning. It's really important when all parties together, and then we're all at the same table pushing the same aims, is that when we really believe innovation can take place. Thank you.
Thank you, Mercedes. Thank you, Rosario. Think you too should have been part of our panel discussion with your last statement. Thank you very much for showing us what's happening on the Atlantis. I hope you all had the chance to go and look at it by now. Two more speakers for the afternoon. Ayesha from Caparol will show us some innovations from their end. Ayesha, please, the stage is yours.
Hello, everyone. It is really a great pleasure to be here and show you some things. So basically, we are today talking or traveling to the time about the EFS evaluation, how this thermal insulation traveled into the history long before, and what is EFS. Being an architect, most of the people are aware EFS is a thermal insulation where we wrap our buildings with the insulation, with the finished coats. These are few layers. So this is a certified system by Civil Defenses. Yes, certified and according to the FLS, UAE FLS. But before going to details, what I'll do, history of EFS. Try and travel with me to the back before BC, before Christ, what was happening. This insulation or the EFS or saving yourself from the harsh climates, it's so old. Even in the pyramid, Egyptian eras, people used to insulate their houses with the mud. They used to build the houses with different kind of stashed, some straw and all those things. And they built the pyramids in a way, kind of a double-mounted pattern so that the heat of the summers will not travel inside, and the nights will be slightly warmer. And if you see the Greeks were masters of architecture, and they used to do this also. They used the double wall systems, and Vikings, they used to use the human skin, the feathers to insulate themselves, to insulate the buildings. Now coming to the history of Middle Ages. Middle Ages, if you see, again, the stashed was the main weapon or the tool to insulate the roofs, making them taper and making them easy to insulate internally. Then comes the industrial stage, Industrial Revolution, and steam powered everything. Steam engines and all these things invented. So it was very important to protect the employees, the workers, from these heating pipes. So they started using asbestos, which was quite a dangerous material, and they had to stop it later. And then what happened? Insulation requirements came into turn, and in 1965, in US fire or the building code invented. That's how the ASTM standards came into the ETAC 00 guidelines, what we are doing for EFS. All these implementations and regulations invented that time. Today, what we were doing in those times, we, Caparol, we were happening in that times, in 1950, we, Caparol, we were busy inventing the EFS system, the thermal insulation. As many of you are aware, this thermal insulation is invented in Europe. This is the screenshot of our factory in Germany, Ober-Remscheid. And what we were doing and who we are, from where we came from, it's a 125 years old company, and our headquarters are Ober-Remscheid, and we are available in many countries like Middle East, East Europe, and other places. Yes, it's German, born German, but truly local. How? Because definitely, according to the weather limitations and condition of this part of the world, we have to get the 60% of the raw materials locally. ICV score is 45%. So what we do, We produce our materials as per the STDAMA compliant requirements, green building, sustainable, and we are also having a carbon footprint which is really low. Here you can see the aerial view of our factory, which is a Dubai plant. We started 26 years ago in Dubai, and we are situated in Dubai Industrial City. We have showrooms also. We call them showrooms. They are the distribution centers in Dubai, Ras Al Khaimah, Sharjah, Abu Dhabi, everywhere. Then Middle East and Africa, we have a joint ventures. Saudi, we are available. A complete team is there. Then, if you see, we are having more than 20,000 square meters of area and more than 30,000 tons of ability to build the materials. EFS, what is the benefits? I will not go into the details because we all know what is EFS, how it works. So, but it's a small study. Sometimes people are saying it is expensive material. No, it is not expensive. How it is? I will just conclude this study of German Institute of IEFU, where we are analyzing the gray energy versus the saved energy. For example, if a normal family single house, let's say the size of 150 square meter, if they are using annually 380,000 to 450,000 of kilowatts energy, they will burn 1,000 liters of oil, means 90 to 120 tons of carbon footprint, which is way more high. Now, let's insulate this 150 square meter family house with 0.2 U value, 120 mm thick insulation EFS system. What will happen? Same house will use now 7,000 to 18,000 kilowatt of energy, less heating oil. Now they will use 700 to 1,800, means less carbon footprint. It's like a win-win situation. How? Total 96% reduction straight away, or return of investment through your energy bills and the living comfort. You will be getting the payback within 2 years. So now, sometimes our developers and the clients, those who are not the end users, they are saying, what is our benefit? Yes, it is the benefit in them for also, because it's a FM certified material, and once they are using this material, it will be good for them, FM certified, and they are getting a good insurance rates. So we, Caparol, what we do? We are having a EFS, yes. How we are different from the industry and other things, we have a big range of finishes. Because now you saw the biggest rain in the history of UAE. So sustainability and the water tightness is very important for the finishes. And we, Caparol, we are the inventors of stone paints, Kappa stone. This is #1 paint, stone paint basically, which is using the nano quartz matrix technology, means the final layer is having a nano coating, the final 3-layer coat, which makes it extremely durable against the weather conditions, and it makes a kind of a water repellent, and this material can be last up to 25 years. So final coat of EFS, you can have this stone paint, or you can have this granito, means you can match the granite effect with this coating, and all these stone coatings are having a natural stone aggregate. We can mix and match any color which is available in the nature. Let's say you don't want the stones, you want to go with something. So we have travertine. Travertine is like a real travertine, and we can create any kind of effect. I will show you a small video. It has a really easy application. So you can prime. Now they are applying the first coat using the trowel. Completely drying. Then the final second coat, you can have any kind of an effect. It's limitless designing, and we have colors also. Fast, easy, and quick. This is one kind of a pattern. Yes, we do have good applicators. We can recommend you. They are the third party. but definitely this is the whole EFS and these things are install laborious work, so we do have a good labor to recommend. By the way, this elephant is our mascot. We added this mascot in 1999. We are taking the durability of thickness of the elephant skin because elephant skin is the toughest skin in the living things. So we are taking the inspiration from there and the rainbow colors. So that's how this elephant is there. Okay, now, other than the stone paints, we have the big range of texture coatings where we have heritage effects, we have different kind of adobe, mud finishes, we do have different kind of grains, any roll color, any Pantone or NCS color is possible to match. Why I'm going back? I think I want to stay on the stage more. This Spectrum Middle East is an interesting app where you can color scheme your internal facades or even interiors. We have a color spectrometers. This is available in 2 languages, English and Arabic. How it works, I will show you in this video. You can take a picture or you can do the live color scheming. So our big fan chart, which has more than 1,000 colors, it is also loaded with this. This is the fan chart. It's just a click. You can take a picture, external facade or maybe internal walls. Take a picture, choose a color, change it. Or do in a live video, which option is also available inside the app. Available for iPhone and Google Play both. Coming to the architectural portfolio, we have a time slot, otherwise I love to talk, and especially when it comes to EFS, I talk a lot. But let's go to the case studies. We have done Blue Waters, we have done City Walk, we have done City Center Zahia. Most of the city centers we have done with EFS. Oasis Mall. This is some recent portfolios which we have. Abrahamic House in Abu Dhabi we have done so many banyan trees, everything with the EFS. Here we added the colors to Expo. Many pavilions we have done. We have done also Vassal Plaza. We have done Expo Village where we install different kind of LGS framings and all those things because we do have also this system which we call SFS. We are doing Rove hotels with our stone paints, and we call it Rove gray color, which they are using everywhere. We are working with Emaar. We are working with Tamak. This is Emaar Park Point project, which is there. Hotels, Rixos Sadiat. We are also doing a lot of schools, MAT, GEM schools, Khaldia Mall, all these Mira Villas. Dubai Hills also we are doing. These are some projects which we have done globally, or maybe I can say the GCC. Nizwa Souk is basically we have done with the Adobe finish. These are some projects in Maldives, Tanzania, and everywhere. So these are some projects. Please connect us on Insta and all socials. Thank you so much.
Thank you, Ayesha, for this presentation. Caparol is also at the back. If you're interested to connect with Ayesha, please do so. The last for today and for this session, Khaled, please join us on stage. Khaled is from Vitro Glass. He is also taking us through some very interesting projects, I hope, in the region and share some insights of Vitro.
Yeah, thank you very much.
There you go.
Good afternoon, everybody, and thank you very much for spending time with me. So I'm going to talk about the embodied carbon and how can Vitro help you reduce embodied carbon. So there was a lot of talk, and maybe I can answer some of the questions that even Susan has brought up today. So PPG Pittsburgh Glass, our story is defined by continuous advancement to improve how buildings and how buildings look and perform. In 1934, PPG has introduced Solex glass, the first heat-absorbing glass, which reduces the heat load on vehicles and on buildings. In 1990, PPG introduced Starfire, low iron ultra clear. And 2015, Vitro introduced the world's first quad silver Soloband 90 low E coating. Throughout history, PPG has continuously raised the industry performance standards. In 2016, PPG was acquired by Vitro, a multinational company that founded in 1909 and operates in 34 countries. Vitro is Mexico's leading glass manufacturer since a century. Vitro has left the same products, the same staff, the same people, the same customers and processors that made PPG a world leader. I must say that PPG is probably one of the most specified glass in the world. I can confidently say that. We are probably, you will see our glass on one of the most iconic and sustainable buildings around the world. And in 2019, we have introduced Acuity, which is an affordable low iron. Now, let's talk about the glass channel. There's a lot of glass companies. People confuse glass companies. Some people come and ask me if I can do lamination, and they go to the coater. So let me explain. The glass companies have different capabilities and capacities. It all starts with us, the primary float manufacturer, where we get silica, soda ash, dolomite, limestone, and convert it into float glass. Then we have manufacturers of low E. They do low E coating on the glass. And then there's the glass fabricators who take that coated glass and cut it into specification, into shapes and sizes that were specified by the architect. And then finally, you have the glazing contractor. This is in the States, and here we have also aluminum fabricator that take that IG unit done by the glass fabricator and install it on the building. Okay, this is not my slide. I'm sorry. You're probably saying, what the hell? Why does he have a half-eaten burger on the screen when I'm supposed to be telling you about embodied carbon? So, well, I want you to keep that theme or idea in your mind for the coming couple of minutes. A cheap, available, satisfying burger will affect your health the same way a cheap, available material will affect our environment. So now let's move to our today's subject, embodied carbon. Embodied carbon is actually the greenhouse gas emission that's associated with the construction and installation of any building material, any building material, okay? That includes the expended energy during the extraction of the raw material, shipping of the product, and installing the product. Then to find a way to measure that, they found the global warming potential. It's basically a measure of the solar heat absorbed by the greenhouse gas emission as a multiple of the heat absorbed by the same mass of carbon dioxide. And that's expressed in kilogram in carbon dioxide equivalent. We're going to talk about this now. So basically, if the GWP of carbon dioxide is 1, GWP of methane is 27 to 30. The GWP of nitrous oxide is 273. Of course, the higher the GWP, the more it contributes to the global warming. So if carbon dioxide equivalent, it's actually calculated from the GWP. If 1 ton of greenhouse gas emission is released during production, it's equivalent to an Earth warming effect of a multiple amount of carbon dioxide. So if we said that methane, 1 ton of methane has 27 to 30 tons of GWP, that means it releases an equivalent amount of 27 to 30 tons of carbon dioxide. And you can find all this information in something called the EPD, the Environmental Product Declaration. This one, every contractor should have it. Okay, so let's talk about our industry. Where does really embodied carbon come in our industry, in the float line? It comes from the intensive, energy-intensive process of heating the melting furnace to a temperature of 1,650 degrees centigrade to convert silica, soda ash, dolomite, and colored glass into float glass. Okay, where does it come in embodied carbon, in the IG unit? 75% comes from what I just showed you in the previous slide, from us, so we're the corporate. And then 13% comes from the fabricator, from tempering and heat strengthening of the glass. And then 10% comes from the IG unit fabrication. And then 2% only comes from the low E coating, which is, as a matter of fact, proved to be beneficial to the operational carbon of the building. Okay, so now let's talk about what are the challenges we're going to face to actually achieve reduced carbon goals, and what are the solutions. Of course, the architect will do his homework. He will find a product that meets the GWP. And I'm showing this over here, this graph, which was actually set by the CLF. CLF is the Carbon Leadership Forum. And for different materials, they have set a baseline that we have to meet or go lower. So it's also worth mentioning that GWP is calculated differently from one country to the other, and also from one material to the other. So that's the goal. Then, in reality, and I will refer to Lars from Pridman and also James today, they talked about this. Once the tender or the bids are turned in, there are products that are not specified that will be attractive to the contractor because of a lower price. And this is where you go for something called value engineering, or you choose a cheaper product. But anyway, so then the whole embodied carbon, overall embodied carbon goals is strained because of a contractor choosing a product because of pricing. Now, how to prepare for this? The glass supplier, we need to go and talk to the contractor, understand, explain to him, and first of all, we have to prepare, see what's the GWP of this unspecified product versus the GWP of our product. Talk to him and see if he's accepting, what level of GWP is accept versus the cost savings. How to solve well, the general contractor has to go on a diet. He has to think and find a product that has the same specifications for his project and that carries a lower GWP that will achieve the overall GWP. This is not CNN. There's nothing about the American elections. But the breaking news is that Vitro has a GWP lower than the industry average. Our GWP was 1,350 kilo of carbon versus, which is 6% lower than the National Glass Association, and it's better than our results back in 2017. I believe this year, 2024, it went down to 1,240 kilogram of carbon dioxide. So now, since we are the culprit, how can we solve the embodied carbon in our industry? First, we need to improve the efficiency with the furnace control systems to reduce variability of melting furnace. Second, we're using variable frequency drives on cooling fans to reduce energy use, utilizing also recycled raw material to reduce fuel consumption, converting facility lighting to LED. Finally, which we are doing in one of our factories in California, using oxy-fuel, which can reduce energy consumption by 20% and greenhouse gas by more than half. It's also additionally worth mentioning that Vitro has submitted in 2023 data for 24 months of production together with the EPDs versus 12-month production data that we supplied in 2023. So I think we're going on the right track. Okay, so since we said that 75% of the embodied carbon comes from us, so you need the contractor, the owner, needs to look at the EPD, because this is where you will find the information and you can make a decision on embodied carbon. So what is EPD? I'm sure you've seen a woman when they stop in a supermarket and they look at the jar, they look at the jar and they look at the information of the food label to see how many calories they will gain or what's the sugar. So EPD is exactly like this. It's the label that tells you all the information about the product and how it relates to environment, how it affects the environment. And as I mentioned here, Vitro is the first North American company to publish third-party verified EPDs. We also have an energy and carbon calculator on our website. Of course, EPDs are very good for LEED credentialing and for green buildings certification. So please, you can go to our website, whatever project you're working on, whether it's an airport, hospital, the program, the carbon energy calculator will lead you. And if you have any questions, of course, you can send me an email. We will help you. So we started with the burger, and we're going to end with burger. Please remember that cheap, available, satisfactory is not good for your health. You better do some extra work, find the product that meets the budget, your budget of the project, and can also meet the overall sustainability objective or the baseline set by the CLF. Thank you very much for your time. And if you have any questions, I'm here.
Thank you so much, Khaled. Thanks for those who made it to the very end of it. I hope you enjoyed it. I hope you took a lot of new ideas, inspirations, and connections with you today. For those who are joining us for the gala dinner and the awards later tonight, I think it's also happening here. Whereas, in the meantime, for everyone else, the exhibition and refreshments are outside. For all the panels and speakers, please stay back for some photo sessions. For the rest, thank you very much for bearing with us this afternoon. And hope to see you, I don't know, next year or at the other Zak conferences in the region. Thank you very much.